Yeah. All right, let's see here. I need music. Where'd my music go? There it is. Oh, jeez. Okay. Wasn't supposed to be hooked up to the mic so soon. Does this look? Yeah, I guess it looks all right. Huh. Very kind of peaky. I don't know if my audio thing is acting up again. No, it looks like it's okay. All right. So much to keep track of. Hey, what's up, Remdog? How you doing? It's been a minute. I took a little hiatus there. Here, let's get YouTube chat up. Pop out chat. There we go. All right. Oh, I need to get the microcontroller over here so I know the sizing. Sizing is important. Was it Twitch acting up or did you go live for a split second a few moments ago? I don't think so. What's up, Hairbothan? I don't know why it would have... Did you see it go live in YouTube? Because maybe it was when I was messing with the YouTube live streaming thing. Because whenever I click into YouTube, there's always like a little cache of stream that it displays before I can edit the video. I don't know if that counts as me going live in any way. I thought that was a local cache issue. Cache issue. A local cashew. It's nuts. All right. That's just too dumb. Too dumb. All right, let's see. If I saw Hairboffin was on Twitch, okay. And then this moderating. That okay. That's looking good. Where's my YouTube chat? Where did that window go? There it is. Okay, cool. I'm all set up. I'm all set up. I'm fine. I'm fine. I'm gonna be okay. Yeah, we're working on the keyboard a little bit more. I've got more design. Let me boot up AutoCAD too, just so we get that out of the way. I've been busy. I've been a busy bee. I've been working on this thing a lot. I want to get this keyboard thing done. Then I'm a little bit more familiar with doing the circuit stuff, and we can circle back on the mixer and try to make things kind of fit. One of the big things, what's that? Twitch just showed something possibly recording as I clicked the button to go to chat. Played an ad and then went to the offline screen. Weird. That's very strange. Yeah, Twitch does weird stuff with the cache. YouTube is worse about it, though. One of the more important things when laying out a circuit board is highlighting the different function areas and gathering the parts so that you get the air wires to be a little bit neat. And I didn't show that last time. That was kind of a big deal, and we didn't do that. But we're on to a new circuit board. I mean, it's unfortunately the thing with working on projects is that a new project is like so enticing. I've not had a backup keyboard though, and I'm getting really sick of the tiny keyboard that I have on this computer. I wanted to go back to my normal keyboard, which is a slightly tinier version of a big keyboard. So I kind of want to get this board designed and ordered, and then we can work on the mixer again and get that working. And then once we get the mixer working, I can circle back to maybe not the module tester. Maybe we go back to the 303s that I think I'm this close to fixing. And then from there, we go back to burn the subs. So we got a lot to do. I've got too much to do and too little bother in the world. There's only one of me. So we are going admin project, stream projects, and I'm going into the CODE QMK takeover. I'm going to open up that design. Like I said, I've been busy. I've been working on this stuff. So I actually made for the, what's up, Spar? Yeah, Happy New Year. Hope everybody has a good New Year. I made these two parts because these are literally just the footprint of the chip, but then I put cutouts around it on the routing layer. And so I will be able to flex those into position in order to basically take over the two ICs. And this is a keep out thing. We haven't done the overall board outline because we need to figure out how we're doing the dip switches. I need to figure out the dip switches, and then I need to figure out what I'm doing with U6. I haven't figured out any of these connections yet because it's been on my computer that I use. So we'll take a look at U6. We'll take a look at $6. I guess I messed up that part. And then once we get the full schematic, I can figure out the physical layout a little bit more, and we can insmollinate this. I mean, the debate is, do I want to use just an RP2040 instead of this? Because I put through holes on the bottom of this in order to get to those test pads. I wouldn't have to do that if I just used the RP2040. If I use the RP2040, I could probably make this whole thing fit in like this area. Just this little area right here. I need to go around this connector, but I mean, it would be pretty easy just to put that in. But then I need a crystal, and I need a power regulator. I mean, it's not a lot, but it's stuff that I need that I kind of don't want to have to design. Kind of don't want to design it. I want to just throw the micro in there. Instead of having to buy stuff, I'm still buying the circuit board though, but I mean, like, if I could just toss this in there. Oh, and I would need memory too, wouldn't I? There's just stuff everywhere today. My shop is getting a little disorganized, and my eye is starting to twitch about it. Maybe I should go wireless with everything. Everything could be wireless. And I would be, like, move all of this disorganization into the radio band. That's a good idea. Or it sounds like a good idea. Maybe it's not a good idea, but it certainly sounds like one. In order to access USB, I have to actually go to these two test points. You can see they're scratched because I've been measuring them. And then test point 6 as well. Luckily, they gave dimensions in the data sheet, but the dimensions go on this corner, and I was going off of this corner here. So it was a fair bit of calculation in order to figure out. Actually, they go off of this corner, and I go off of this corner because we're flipping it around, right? We're viewing through the board. It's a pain in the butt. It's a big pain in the big butt. I was wondering if I could use one of the Seed Studio Zhaos as well. Like, those have way fewer pins, but you can see we're not using a ton of pins off of this micro. We're not really using a ton of pins. I mean, we've got our analog signals coming back. We have our trigger signals for the muxes, and then we have a screen. It's not a ton of stuff. So I mean, all of these considerations are floating around in my brain. I don't want to make too much of a meal of this thing. How many are we using? 1, 2, 3, 4, 5. Wait, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 pins. I don't think we have that on the Zhao. I don't think we have that many. The Seed Studio Zhao. Zhao also is wireless, so I could probably make it like a wireless keyboard if I wanted to. I don't really want to incorporate a battery, and I don't know what kind of power regulator this thing has. One, 2, 3, 4, 5, 6, 7, 8, 9. It's at 14 pins. I don't think we can do it in 14 pins without a port expander. And a port expander, I think, would add a little bit of delay. So, oh well. So much for that idea. Because, yeah, we only have 10 pins. That ain't going to work. That's fine. We'll use the cheapo RP2040 in, what is it called again? The Pico Pi. Pico Pi. Ah, man. I'm still recovering from New Year's. I haven't gotten a good night's sleep in a while. I watched a little bit of Squid Game last night, and I don't remember where I left off. I think at a certain point, my brain was just like, nah, we're not recording anything new now. I'm like, wait, who makes that call? Why, wait, hold on, I want to remember stuff. No. How much trouble can you get in if they find a universal display key, like a public display key in your bag? I don't know who's searching my bag anyway, but this is for like getting into those posters at like subways and stuff. I mean, it works for a bunch of other stuff. It's really just kind of a public security key. It's like a janitorial key. But if I have this in my bag, feasibly, what kind of trouble can I get in for it? Bought it on Amazon. I mean, maybe no trouble. I think the reason I took it out was I was flying, and so I didn't want it to be in my stuff. But it's got the triangle, it's got the 2 squares, and then it has the little city key kind of thing. Doubt anybody would give you trouble. Yeah, or know what it is. It's what you do with it that gets you in trouble, I guess. But it's like carrying around lockpicks. I'm actually going to put that in my key drawer. There we go. I don't know why it was out here on the desk. I think it just came out during when I was packing for a LAN party, I think. Oh, we need to do a whole session. Now that I've got my ADHD drugs, I can do things like put chips into their bins, their proper bins. I've had this pile of ordered stuff that I've been meaning to get into the rest of my stuff, get it into the whole system of organization in the shop. Can you get in trouble for carrying lockpicks even though it's you know it's not illegal? You can just get in trouble for it. Maybe not. Maybe I'm exaggerating or whatever, interpolating, extrapolating. Where are you with? Depends where you are. Ah, yeah, I suppose so. What's up, Lawn Dog? Good morning, oh bother, and of course, Happy New Year's. What is this, day 2 of the new year? Yeah, we're in day 2. Day 2, and it's already been a long year. Oh boy, what a wonderful piece of imagery, that Cybertruck burning in front of Trump Tower, because it's both a Cybertruck on fire, it's a dumpster fire, and it's in front of a dumpster fire. It's amazing. Like, what an image. What a wonderful image that they brought us, the chaos of the new year. Day 1 of the new year. A unique attack. I wouldn't really call it an attack. It's more of symbolism in the wild. It's an artistic expression. Really appreciate your efforts. A bit off topic. Oh, this is a comment that somebody left on one of my videos. OKX wallet holds some USDT. And I have the seed phrase. Wait, what the fuck is that? Wait, somebody's... What the... No. What the hell is that? This is somebody advertising something, I think. I appreciate your effort. A bit off topic, but I wanted to ask. My OKX wallet holds some USDT, and I have the seed phrase, and then he gives the seed phrase. That is a fake comment. That's just... I don't know what to do about that. Should I just like remove it or report it? How can I transfer them to whatever? This is like the fakest thing I've ever... It's so fake, but should I pin it? I should pin it at the top of the video. I'm just going to remove it. We're just removing that comment. Hey, oh bother, here are my banking details. It's like, come on. You're not even trying with that one. Put in a little bit more effort there, scammer. I have this wonderful old gauge that I don't know what to do with. It's been sitting on the desk for the longest time. It is an AC milliamp meter. So this is for alternating current, and it's measuring milliamps, and it's this wonderful old gauge. You can get these for like 30 bucks, I think, 40 bucks. You can look for vintage gauges on eBay and get a lot of really cool stuff, but AC milliamps doesn't really come up all that often, so I don't know what to do with it. If I ever do like a car setup, you know, something like what Gonad has, I could probably take it over and do something with it, but I don't know how you even... You'd have to do like a resistor trick to turn it into... Well, AC milliamps, we could actually measure some of the music stuff using this. Yeah, the milliamps for AC, I would have to figure out how to control that with a microcontroller. Would be the best way for me to turn this into something like a speed gauge or something. But it's such a great little gauge. It's such a nice little piece of equipment. I wish I had more stuff like this. I do have some vintage gauges and One of them actually bit the big weenie in the sky. It fell from the shelf. Something shifted on the shelf, and it just went straight to the floor. So all that effort we put into cleaning it up, it's dead. Dead. It's a dead gauge. Bridge rectifier, it has to be AC. So I was thinking you could do like a DAC. You could do I2S to a DAC, and then the DAC could run an amplitude for a waveform. That's all I can really come up with, though. I don't know how you would do that more simply. I mean, you could do a Sallen key filter with a PWM input, and you would have a PWM table, and then the amplitude you would just be controlling. And then the more amplitude, of course, the more the gauge moves back and forth. That's all I could really come up with. And then what I really wanted to do with this was even cooler. You'll love this. So this gauge, I want to put in one of those glass jars, you know, with the round top, and have it hooked up to the chip that I really want to get, and I haven't gotten around to getting a radiation hardened version of this chip. It's probably going to be expensive, but there is a nuclear event detector. It's a chip that senses RF, and so its 5-volt line goes low if there is a nuclear event. Seems a bit weird. Why? Oh goody, we've detected a nuclear event. What do we do now? Die? It's for like data hoarding, where like if there is a cloud burst, like a nuclear cloud burst, it'll park all the hard drives and, you know, get its data ready to withstand a little bit of radiation and then come back up in the apocalypse. So I want to have this gauge on that, and then maybe like a note that says like you're fucked or something like that, and have what I would do is make it look like it's very forwardly connected, like it's just blatantly connected to this thing, but then have hidden wires that go down to a microcontroller, and the microcontroller every now and then would make the gauge kind of go ooh, ooh. At some random interval. I think that would be a great display piece. Oh yeah, I'm not throwing away the meter by any means. It's the one that broke that I'll probably... Buying that will increase your level at all the alphabet agencies. I get to be on a new list. A list made specifically for me. That should be all of our goals anyway, is to make the FBI make a new list for them. Yeah, it's 0 to 500 milliamps, actually. 0 to half an amp. Here, let's see. I don't think there are any resources for buying this chip. Oh yeah, we've got all this information up that I don't really need anymore. JLC PCB has like, here's 40 tips for making a flexible PCB. I have done a little bit of homework. I actually have done a little bit of homework and did just a little bit of research. I don't think we're going to use a bare RP2040. It would be kind of cool to do that, and I could definitely make this a lot smaller, but I think the module itself brings with it the power supply and the crystal and all that other stuff. It's worth the $5. Hey, what's up, Ben Gizmo? Yeah, Happy New Year. And then Willow ate your homework. She does love tearing up paper, so that could very well be a possibility. It is within reason that Willow would eat my homework. I mean, to be fair, like, I don't need to use this stuff. I could use my own stuff. I could use like an LM1117 on the 5-volt line. I could use a bigger crystal. I don't need to use that tiny ass little thing. But then there's like this EEPROM over here. I don't know what's going on with that. Hey, watchmakering, how you doing? How you been? How you been? How you doing? These dimensions were kind of crucial because the 3D model that I got did not have the test points on the back. So I put a lot of effort into getting the test points right. At some point when we get a good board design going here, what I'm going to need to do is print my design onto a piece of paper. And to print it onto a piece of paper, you can do all the cutouts that you need to do, and then you can have a physical representation of your board in 1-to-1 scale. You know, you can also 3D print the boards. I know it's a fairly boring 3D print. You just print out a square, but it's good to actually, yeah, the testicle points. It's good to actually have all of that stuff like physical in your hands, and then you can line it up and see if everything works out. Because my PCB is going to rely on soldering the module to one side, and then from the other side, you have to solder to the test points, which is another argument for putting down a bare RP2040, putting the clock down, putting the voltage regulator down, and that could potentially make this design very small. I mean, I could go right up to this connector on this side, maybe preserve this, and then, I don't know. These are measured very carefully, by the way. If you see the origin point is down here, that's because I measured from this corner of the main PCB to get these measurements. What's up, Kiro Aoki? The people on Twitch hear music. My God, it's amazing. It's like there's music playing. On YouTube, you won't be hearing music. You'll hear silence. But what it is it's DJ, where is it? This is the wrong one. DJ Everyday. It's a buddy of mine from PEX, Philadelphia. Yeah, check his music out if you feel like it. Anyway, yeah, so I'm just kind of going over this design because it's real fresh. This is supposed to be our start soon time. I forgot to put that up there. Can't get Dragon to display both sentences correctly. What? Oh, 0 to half an amp. You gotta 0 to 250. I see. You're running into all these problems with speech recognition going crazy. Yeah, the wonderful world that we live in today means that AI is starting to become more pervasive in areas that we never wanted it to. Like, we had pretty good speech to text going on, but then somebody decided to insert AI directly up its anus, and now when I swipe type, it thinks I'm saying dumb things. I can't use my smart person words. And then it eventually learns it just in time for there to be some kind of an update to the whatever the pool is, and it goes back to being dumb until I train it away. But I get like a week of like nice swipe typing and text to speech, and then it goes back to being dumb. It's probably better for everybody else. There are people who likely are experiencing it getting better. I don't. It's going to be interesting when it gets integrated with quantum computing, which we're currently working on. I don't know, man. It's all going in a direction. It's all going in a direction. We're gonna stay behind. We're gonna mess with antiques. That's what we're gonna do because we're good at that. I'm good at soldering. As all this AI proliferation heading towards the singularity, creating quantum worlds when the one we've got is stinking. Come on, hands up. Anyone who thinks they got it right. Sorry, it's from an Orbital song. Image related to your mention of the Cybertruck. Oh, is there? Let me check Discord activity. Oh, somebody made a cyberpunk version of it. Yeah. It is. I mean, we've got the image of the year already, and it's not even day 3. So we got to figure out what I've already got here. What I did. We got to figure out what I've done. Yeah, I don't know if it will, man. I think it'll probably be bending down to corporate overlords in some kind of a mega high-tech plagiarism scheme, because that's what it is already. We've created artificial life, and it's entirely plagiarized. If AI does count as being sentient at some point, it'll be sentient and stolen. Where did my spudgers go? Where are my spudgers? I guess I didn't have them out. I don't know what happened to them. I mean, I can go back to using this one. I guess this one will do. These are just clay working tools. You can get cheap clay working tools. They're also dental tools, but I've been in this keyboard so much. I've been debating, like, if I can get my hands on a CNC, if I can build one or, get one, a CNC router I would like it to be able to be large enough that it can that it can route some burl wood and make me the two halves of the shell that I'm piecing apart here. And if I can do that, then instead of having snaps, I'd use magnets. Just magnets and maybe a lip to detent on, and it'll just go plump and just you know, hold on for dear life. With the power of magnets. Up, cheese popcorn. Recently started using the built-in AI that's in VS Code to help me PowerShell. Help me write PowerShell scripts, and it's great. Well, I mean, you know, to a degree. Programming is just like advanced plagiarism. It's like, you know, you put out your code there for other people to use, specifically to plagiarize. It's like, just steal this. Don't do what I did. Don't make this up. Just come use my stuff to propel mankind forward in the realm of programming. And so, you know, you just kind of accept that with programming. And having AI do it in programming, probably actually a really good idea, because it seems to be doing a pretty damn good job. Flatulent Gonad's been using it to create chat display on his VFD screen. He's got a couple VFD screens. He bought a couple more after having destroyed all of the other ones. I think he got kind of mad at it and broke them all. So now he has it once more, has it programming. I don't know what he's using to make it happen, but he's using something to program these screens to display chat for him, so he can read chat while playing games. And they're brilliant. They're really nice looking, these VFDs. But ChatGPT has been instrumental in helping him do that. God, that unplug is so violent. I actually think I broke something. Yeah, I think I broke something. Uh-oh. This is the part that I need to reverse engineer, too. Oh boy, we'll have to figure out what the hell I was doing here. Some facet of my keyboard is now not going to work. Great. Mystery. We got a mystery afoot. I don't remember why I did this. And so we've got to figure out what I did and why I did it. This circuit here broke just now when I was unplugging this thing. And it looks like the two resistors broke off. They're not very strong. So I'll need to figure out what the heck I was doing here and how to fix it. It looks like I'm flipping 3 bits. And the black wire is probably going to here. So these 3 on this side, and I'm using 2 over here, which I don't know what they're doing. I should have taken better notes, better notes, better notes. I spent a ton of time reversing old Hall effect keyboards. Where are you getting Hall effect keyboards? That sounds advanced. That's neat. I'm going to clean off the desk a little bit here too, because I need room to work. And the desk is completely full of plastic. Completely inundated with plastic and circuit board. When the stream's over, I got to piece my keyboard back together so I can use it again. I can't believe I just broke it by unplugging something. That was dumb. I got to be more careful. This plug is a bastard. It's not really meant to be unplugged. All right, what's going on here? There we go. What's going on? It's your boy. Like, comment, and subscribe. I'm trendy and hip. How you doing? Rhine Labs. Rhine Labs. Try to do my best Sarsgaard and no, not feeling it. Not doing it today. Nope, can't do it. Can't do it. Can't pull it off. Yeah, start doing an impression. You're just like, nope, that's not. Nope, not doing it today. Soldering iron next to me, put to good use on one of my projects. Hell yeah, do something. Get to it. Get busy. All right. All right. Looking good. We'll start up in just a minute here. I think I'm feeling a little bit more organized. All right, yeah, let's just get started. Let's get started. 3 to 4 calls a week to be a tester. There's a Rhine Laboratories that tests 420. What, tests pot? Is that the Rhine Labs of cannabis? Well, what a note to start on. Hi, Happy New Year, everybody. We are still working on the keyboard because this is like a quick project that I can just kind of hit out the park. Previously, I actually modified my keyboard to use an RP2040, the Pico Pi, to run QMK, Quick Mechanical Keyboard. The challenge of it was that the CODE Tenkeyless keyboard has a weird set of rows and columns. What they decided to do is on home row, like where your hands are sitting, they decided to split those into several different rows. The rows are split up. It's not just a big grid. It's actually little bits of grid so that when it's scanning through its rows and columns, it'll scan where your hands are more quickly. That's the justification behind it. I didn't do anything to make that a reality. I just sort of used their pinouts and everything and tried to learn it on my own. There were a couple gaps in their grids, so I moved a couple columns together so that they would scan their rows all, as one. There was a lot of that kind of work, and I've got all of that data written down very carefully because it is a mess. That data is not in this one. It's in the other one. Oh, I need to open it up. File, open recent. That would be, no. Well, let me start a new instance of Paint. That's what it is. So hold on, Paint, MS Paint. So CODE Tenkeyless sonics.png. I think one of them is stored locally because I can't save from this computer. But figuring out where all the rows and columns were was a mess. I basically had to go through and ohm out all of this stuff. And so here is the row and column setup. I don't know why there are arrows here. I don't know what's going on with this. Some of them got swapped because of the convenience of wiring it, which was what this plan was here. See, this keyboard uses 2 microcontrollers. One of them stores the other microcontroller's code just to do a factory reset and controls the lighting, and then the other microcontroller does all of the keyboard stuff, including USB communications. They love their Sonics microcontrollers. Some of the internet designins of the keyboarding realm have actually figured out how to run code. In my case, though, I took the whole thing over with QMK by using the solder pads that were on the board and running it through a bunch of Max 308s. I would not suggest that you use Max 308s. I happen to have them because a long time ago in the early 2000s, I worked on a brain imager, a brain scanner. It was something that looks at the light reflecting off of your brain in order to ascertain how much you're using parts of your brain. So it needed to mux a bunch of analog sensors. So I've got buckets full of these Max 308s that you guys can't see right now. I've got buckets full of these Max 308s, and I've decided to use them as the muxes for this project. I could probably source another mux. I'll catch up with the chat in a second. You guys are very chatty, and I love it, but I need to get up to speed with this project right now. So yeah, anyway, the Max 308s I happen to have, so we put those on the board, and we got this whole thing running, including all of the lights. The one thing that I didn't really get running program-wise was the caps lock and num lock, but I still have the option to do it because all this stuff exists on the board. What we need to do is we need to figure out this last little bit of reverse engineering because I've been a busy bee. I have been a busy bee, and I've been designing a flexi PCB. This is my first ever flexi PCB. It's a quick project that we can knock out of the park. If I can put just a tactile button in this location instead of having to run traces all the way out to it, that'll save us a significant amount of space. I can make the board much smaller, and I would kind of like to do that. The other way to make the board smaller, of course, is to move over to just the RP2040 chip. I figured that's going to carry with it the need to design a voltage regulator, and then I'm going to need to put a clock on this thing. Those are not hard. I guess I could do that, but we're sticking with the module for now. I've had to do a lot of different measurements in order to get to the test points in the back of the module. So a crucial part when you're designing a PCB is this mechanical layout. There's going to be a lot of issues in the mechanical layout that you need to get through. Am I going to have enough space for my traces? Am I going to be able to route this stuff properly? Is this going to fit in the enclosure? What's going to, this, that, the other thing, right? So we use the 3D model and we use the 2D representation of the board to kind of get through that. And once we do, we can then concentrate on the actual trace layout. Right now, I'm just trying to get through the physical stuff, get it all in the right position. So once we get a final circuit board, we kind of finalize the schematic, we finalize all the mechanical things that we need, we kind of finalize the shape of the circuit board, I can then bring in an actual physical printer, just a paper printer. I can print it out on the piece of paper. You can test layout that way, and then you can also test the mechanical stuff. Lay it down on your circuit and make sure that everything works properly. So what I've done is I've designed these parts that are offshoots of the regular part. I use the copy function so that it's got the same schematic symbol, but it now has a new package. And the new package is no chip. There's no chip there. I'm using the same footprint, and I'm using JLC PCB's spacing requirements. There's a lot of weird calculation that I had to do in terms of like, oh, but this pad is located at this point, which means half the distance to the edge of the pad, and now I need 0.2 of a millimeter beyond that for this line. There's stuff like that. I did a lot of calculations like that, but those are basically what they'll do is they'll fold down. And so having them be the exact same pads, but on the edges of the board, means that when I fold it down, it'll be resting somewhere mid-pad, and I can solder bridge the two. No, I won't have stiffeners. Fusion 360 does not do stiffeners, from what I understand. Now, there's probably a way to hack it and to do a stiffener. They want you to use easy EDA, I think, in order to do the stiffeners. But I mean, if you just have that layer, you can just draw them on that layer, I guess, and then have stiffening. But I can't. I'm not going to do it for this. This is just going to be flexible PCB that I'm going to have to just carefully bend. But and it won't be like, there won't be a stiffener under this chip. I'll just assemble it on a flat surface. There had to be a little bit of overlap from the solder mask to have these pads here, because this thing is going to be heavy. I don't want it to pull away. These I did not do anything with. I'm just using the normal surface mount part to make these. So those might be trouble, but they're a lot lighter than this big module board. So I think they'll be okay. I think they'll be okay. I like easy EDA. It's all I use now. I've not messed with it. I don't know much about it. So, okay. One of we're going through the mechanical stuff right now, right? We're trying to get all the chips in the right position. I did all that boring calculation in the background. We need to finish the schematic. So let's take a look at what I have on this board. I need to repair this board because I just broke it, versus what we have in this document, the MS Paint. Did I close the MS Paint document? No, it's right here. We need to look at what's in the MS Paint versus what's actually on the board itself. I think all of this is accurate. I just need these pins here attached properly. These go to that other microcontroller, to the second microcontroller. And then I've got whatever this pin is. Where's my mouse cursor? We have 3 of these, right? I think. And I put that in there to invert it, I think. So what did I build? What did I do? This is like a last-minute modification that I did in order to run the LEDs of the board, and I just broke it by smashing my hand into it. I think this one, let's get the tweezers over here. Unplugging that cable is supremely difficult, and your hand flies away once you do. This is like on life support here. Oh, okay, so this went this way. Ah, geez, shaky hand. Shaky hand. Shaky hand. So that broke. We're going to have to get another 102. We're going to have to get another 1K. All right, let me catch up with chat. What have you guys been saying this whole time? You guys been typing and typing and typing? I'd unscrew a bezel to relearn which mux is used. I gotta look up new muxes because the muxes that I have are slow. They're for analog switching. They're not for digital. I would not suggest that you would use these. I just happen to have a bin full of them, and I've had no need to mux analog in a long time. Just because all the microcontrollers that we use have like 20 analog inputs, right? You just use those analog inputs. I've not needed to mux between a gathering of sensors. I hate flex with embedded dies. Inner is printed carbon for bonding. I don't really know what you guys are saying. I don't know what you guys are saying. EasyEDA Pro runs on your PC. Use that one. Oh, I see. You guys are JLPCB design rules. Oh, so EasyEDA has the JLPCB design rules in it. I downloaded a file. I was able to find somebody who made a DRC file for Fusion 360 and just downloaded it and put it in. I probably could also just go through it manually. I don't know if they've changed their DRC, but we're using their normal DRC for the flexi PCB, so there might be a little conflict there. Anyway, yeah, so I guess the three, well, where are they coming from? Hold on a second. What did I do? So that is a generic, what do you call it? Generic transistor. It's a 3904 equivalent. And the 102 goes to that pin. I think these two were sharing the ground pin. So it's going to ground. So we've got a 1K coming from the digital pin, and then this one goes to ground. Okay, all right. So I'll be able to fix this and everything. Let me get my 1K resistors out, and we'll just do a quick little fix on this thing, and then we'll jump into CAD, and I can write down this schematic, and we can get it on the board, on the PCB. Now, I don't know, like any pad that I have, have you, Ryan Labs, have you done a flexible PCB before? Because I've never done one. For things like your normal ICs, like an SOIC, do I need to do the thing where the pad is wider and it has overlap on the solder mask? Does that need to, oh, their DRC changes often? Oh boy. Well, I might need to update it then. All right, let me find my 10K resistors here. I don't know where they are. They're in one of these things. High rose plugs. Nope, that's not the right one. Gate driver. No. Singular op amp. I have that? Oh, but it's for like instrumentation. OPA 37. It's an SO8. Yeah, that's huge. Why not put a dual hop? It's cheaper. All right, let's see here. I've got one of these bins just has 10K and 1Ks. There we go. 1 kilo ohm. I'm gonna need 2 of them. Grab a cluster that's been welded together with coffee. I spilled my coffee on this bin a long time ago, and it fused some of the chips together. Some of the chip resistor chips. Got just a little bit of coffee on them. Just a little bit. For fun. All right, so let's get this replaced and fixed up, and then we'll document it. I'll have to pull up an LM3904 SOT23 to get the proper layout of the transistor inside of this chip. It's bonkers. The actual symbol for the LM3904, right, is a bar with 3 things coming off of it, right? Bar with 3 pins coming off of it. That's the schematic symbol. The part itself is a bar with 3 pins coming off of it. So one might think that the internal component matches the schematic symbol. It would be a nice, tidy little thing. Nope, not at all. That's not the case at all. You're dumb for thinking that it should be that way, because it's actually twisted inside there. It's not the same layout. And they did that because having the 2 pins on one side makes it easier to do layout. Access to the LCSC database. Is that the parts database that I understand? I think I've perused that before. I mean, personally, I don't trust parts that I haven't used in designs, or I haven't edited myself. It's sort of after so many years of using these programs, you kind of get cagey about that sort of thing. It's like if I hadn't had a personal touch in the part, weird stuff can sometimes happen. Like some people like to have parts in particular layouts in order to aid soldering it and stuff. And so I personally like to have my own group of parts that I sort of draw from. But that's kind of an old way of thinking, isn't it? Relying on public databases is a long established thing, huh? I genuinely messed this up by raking over it with my hand. This is all kinds of broken. So there's I think three lines do the main backlighting. And it's 3 different transistors that are doing it. And I don't know why. I think I put this in here because it's sourcing a lot of current through them. Too much for the RP2040, I believe, is why we did it this way. You should always review the footprints. Yeah, I just, you know, Fusion had library.io for a long time, but I've learned to not trust anything. I've learned to not trust. I'd rather have a 95% complete footprint than having to make it from scratch. It's not that bad. You're only dealing with so much. You learn how to make the part pretty quickly. I don't know. Fusion has that little part generator thing that I find to be pretty good too. It'll make your part out of measurements for like standardized stuff, and then you can add your own little flair to it. That's how I did the dip switch. Well, the dip switch doesn't have a complete model. It actually just has it looks like a dip package, not a dip switch. I did download some dip switch models that I could easily associate, but I haven't gotten around to it. This is just a massive amount of solder bridging in order to put this together. Now I'm fixing it with a massive amount of solder bridging. How did you fit? How did you fit together? No, this is all wrong. Hold on. You let go, and this needs to go a little bit more horizontal. Oh, and it's a ground pin, so it heats up. Why is this getting worse? Stop getting worse. Flux is making it really sticky. Yeah, footprints in the datasheet, and actually even DigiKey, you can now like download the 3D models and footprints and stuff too. It's getting a little bit more connected, and it's becoming a little easier to author a circuit board. And all the models are a little bit more standard nowadays. There we go. Okay, so that allows me access to, and what am I doing here? Are these both? Oh, see, this one's, you can see 1A. This one's right side up, which means that the collector, or the emitter is here, and this one's upside down, which means the emitter is here. So that way I'm able to just kind of fit them both in this space right here. Okay, that didn't solder. Fine, that's fine. That's fine. That's, you know what? That's fine. I'm not mad. I'm not mad. I'm not mad. I'm not mad. It's fine. It's fine. Really, it's fine. You know, you know, it's fine. I think that it's fine. Okay. Now this one is upside down, so it's a little harder to solder. I could bend the pins, but I don't trust bent pins. Call me whatever you want. I don't trust bent pins. Position there. And I can achieve that with just a massive amount of solder. Excuse me, I think you missed the part where it says hashtag AutoCAD ad all over my stream. What are you, Easy EDA? Never heard of it. Sounds like some loser program that doesn't work at all. Sounds like that program will leave you crying where Fusion would solve all of your problems for you. This is a Fusion 360 household. Okay, so these three lines that I've added stuff to, it looks like it's going down to ground. So this is 1K sort of 1K resistor buffering us, and then these are connecting to ground, and it looks like, hold on, there's stuff in the way. I need to get a bin for the audio stuff. Looks like it's going down to these. Goes all the way down to these three. These two lines are for the numlock and caps lock, I believe. We'll have to maybe ohm that one out. But then I have to associate schematic stuff with this. So this comes in here, it goes through another buffer. There's a pull down on it, I guess. This is pulling down to ground. Wait, if there's a pull down on it, that means that, well, that's interesting. Oh, I don't know. All right. So this looks like it's this part times 3. And I'm hooking up to these grounds with a 1 kilo ohm resistor. So I did note this down. So now we actually have to put it into Fusion 360, which is as easy as can be. Hashtag AutoCAD ad. If you already have the parts in it, it's nice and easy. Just a matter of putting the schematic down, but yeah. I did a PCB from a scan. That's one thing that we have done here as well, is take the scans into GIMP. Which, by God, like, could you guys just rename your software, please? I'm tired of talking about my GIMP publicly. It's a very private relationship I have with this image editing software. We have a safe word. But yeah, it's so annoying that they call it that. But whatever, it's a Linux project. But it's very, very useful, that Linux project. All right, so this would be the chip. I put in an equivalent to the chip, and I made a special part that had all of the routing layer on it. I didn't know AutoCAD did electronics. Well, you'll be happy to hear that there is an extensive suite of electronics included in AutoCAD Fusion 360. They don't pay me to do that. They don't pay me at all. Actually, they give me a free copy if I do these hashtag AutoCAD ad streams, and I'm just being a funny, silly guy. So they basically said you can have the software if you do a couple of these every couple months. So that was really cool of them because I use this software anyway. The reason that I'm using AutoCAD, the reason I'm using Fusion 360 is because AutoCAD Incorporated bought Eagle. And I was using Eagle to make my PCBs. I am old school. I am from an era when PCBs were like $100 and you got 3. You have to wait a month to get them. That was the cheapest that we could get PCBs for. And in order to make those PCBs, there were extensive tutorials on this program called Eagle. And so I learned Eagle through SparkFun Electronics, etc. I had been using PCB 123 and these programs where you basically, it's like MS Paint, but for PCBs. So I moved over to Eagle and I learned a little bit more serious CAD. Probably should have pirated Altium and learned that, but instead we're here with Eagle. And so Eagle got bought by AutoCAD. And at that point, we had been getting into 3D printing. So instead of Inventor, I went to Fusion 360. Fusion 360, oh my God, it does everything. What really attracted me towards this PCB software is the fact that it can do a 3D render of a PCB, and it does it in Fusion, which is important because Fusion is pretty. It's pretty. That's as deep as it goes. That's as deep as it goes. I'm not using this program because of any of the other features other than that it looks really good. That's it. Other programs have been catching up, for sure. But Fusion Eagle, I'm already used to how things operate in there. So when it comes to 3D printing and designing circuit boards, I'm able to go from napkin all the way to fruition. The camera here was a 3D model that we got online, and then I got a 3D model of the PCB that Group Gets made. We put them together, and then we designed a little 3D printed shell to go around the camera, and it's perfect. It works great. It keeps my 3D. It keeps my thermal imager from falling onto the table. Right? Works a charm. And so that's what Fusion 360 brings to the table for me. That's why I'm using it. And I know you can do. Oh, you could design solids in FreeCAD. You can design PCBs in what is it called again? Oh, my brain. The brain has crust on it. I need to like crack the crust off and then blow it and rub it a little bit. 30 years ago, PCBs were quite expensive. Yeah, getting your own custom PCB made. You didn't even get a solder mask. KiCad, thank you. Sorry, it just left my brain. So you can use KiCad, you can use FreeCAD or whatever the hell I mentioned earlier to do all this stuff. It just so happens that my 3D design tool and my PCB tool got incorporated together. There are some hurdles to overcome. There are some hurdles with the software. Any CAD software is going to burn you in certain ways. If you get a free CAD software, things are going to be janky. That's just how it works. This is free if you want features and storage and all that fun stuff. It'll cost you a pretty penny. And by a pretty penny, I mean one that's worth about $380 a month. So yeah, unless you're a creator and you want to just bend over the barrel. Fusion 360 price. Prices and planning. Oh, 1 month for $85, $680 a year. Oh, I got it totally wrong. Wow, I was completely, yeah. So 3 years of it is $2,000, $680 a year. That's not unreasonable. It is a lot of money though, but it's a good program. I actually use it quite extensively, and you'll see YouTube creators who also use these programs. You see their 3D renders. Oh, that looks nice and clean. Oh, that looks exactly like AutoCAD. Wait a minute. So here's what we're doing. We're designing a flexi PCB because JLPCB has them for $2. And a $2 PCB makes it so that I don't accidentally break all of my transistors when I unplug my keyboard. This plug right here is just a bastard. And so what we'll do is instead of this, we can have this, and it'll be laid out properly. And this looks weird, right? It looks like a weird jaw. Looks like a weird jaw. Speaking of which, Pendleton Ward is actually streaming. I was watching that earlier. So yeah, we have a part that actually has all of those little connections on it. And so what I'll be able to do is bend the PCB down and connect to all of these pads. I have to solder bridge across them, but yeah. Are you making a keyboard? No, a long time ago, my keyboard broke because I spilled shit on it. My keyboard broke, and so I decided to use an RP2040 because CODE, the maker of this keyboard, unfortunately, SteelSeries and CODE, I have like fucking Stockholm syndrome with. They keep selling me stuff that fails me, and I keep buying new stuff. I love this keyboard, I really do. It's the Cherry MX Clear. No clicky on the keyboards. It's got a nice little weight to it. It's not, oh, my springs are the worst, I'm the manliest. It has a nice throw to it. It has a nice size, and it's comfortable. I like it a lot. So I bought another one. It's a backup. And then I spilled shit on this one and broke it. So right now, I've got a mutant keyboard that has the indestructible RP2040 circuit on it that's up high and away from the moisture. And then I have just a straight up broken keyboard. So what I'd like to do is design a circuit so that I can rip up all this stuff and get rid of all this and just have an actual flexi PCB that sits on the back of the keyboard and does everything I need. That's the idea. Beam Spring F104, what is that? Oh, it's a keyboard. Okay, I've talked about so many different expensive things that I can't put together of a price tag of $400 and what object is being talked about. 200 grams. Look, I use Cherry MX clears and I think it's got a nice throw to it. I would like to get rid of this. This is positioned very carefully. I've very carefully positioned these things. Beam springs are the 80. No, it's buckling springs. Yeah, I don't know. A friend of mine did his mechanical keyboard, and he did it in such a way as to have everything had like super ultra weight to it. And I was like, why are you doing that? Why do you want to torture yourself having to like get a running start in order to hit the keys? So, okay, these 3 lines here are connected to transistors that are actually physically, you know, something I need to add to the PCB. So let's get that down in the schematic and let's get the pins right. And then I'll have to figure out where these go. Where are these going? These are going somewhere too. Mostly I have everything documented, but it's too bad. It's too bad I needed so many of the pins. I needed so many of the pins of this microcontroller that I can't use the smaller RP2040. It's possible that maybe I could do some very clever muxing and reduce the number of pins, but yeah, what I think what we're gonna do is I'm gonna use these pads and maybe just have like what I did here. You just have this one pad break out. But what I really want to do is solder this to the board, because this is you have to hold this down and power up the keyboard in order to rewrite the software on it. So we just used the pin posts in this location. I could do this again, but it would be cleaner if instead we could just pop this sucker off. I don't think I can do that though, because I think these are rows and columns. So maybe I just need to have a reset. That's unfortunate because I went through all the effort, all the effort to not have a wire connect the reset button. That's what this right here is. This pin is designed to be soldered from the other side of the board, and it interfaces with the RP2040's test pads underneath. So there's a couple pins that aren't broken out on this board, and the pins that aren't broken out instead have these test pads. TP1 is ground, 2 and 3 are D- and D+, and then TP6 is our button, the button that allows us to boot select into programming mode. And I want that button to be here so you don't have to take apart your keyboard in order to program it. GMMK links key switches? Weird. There's a lot of weird stuff in keyboards. They've gotten kind of crazy with it, and I'm surprised that that hasn't bled over into mice yet. I think people have tried to do the mechanical mouse thing, but they just, I don't know. People like that Omron click. What else did I do to this? Some of these extra lines, like that's a ground. Power, I think, is coming from somewhere over here. And then 2 lines going here for the backlighting, for the num lock and scroll lock, I think. Because those go up here to, where is this? I'm like pushing stuff on the desk. Up here where num lock and scroll lock are, they're under this big thing of wires. There's 2 transistors in there that I think go to these 2 down here. What up, Weaselbox? Happy New Year. So, okay. Yeah, the clackety Omron is pretty much universal, I guess. Okay, so this goes to 2 pins, and those are, okay, let's get this correct. That's pin 1, so we're on the other side. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, and then boom, boom. 1, 2, 3, 4, 5, 6, and then boom, boom. And that's going to be our num and caps. So backlight enabled, NC. Oh, num caps lock. So NCC, NCN, and then BRG, BGR. 1, 2, 3. Are those actually populated on this? All right, so something else is going on here that I don't understand. So what, 39, 38, 37, 36, 35, 34, 33 is a ground. Where is that one? Yeah, ground 33. And then 32 is backlight enable. 31 and 30, I think, are the other two that do the same thing. No, they're completely different pins. Okay, so ground 33, the one right next to it is 32, and then we go blank, blank, and then we have C. Oh, wait a sec, one of those is ground? Yeah, no connection, C, skip. So C, skip, and then I thought it was BGR, but I don't know if that's correct. Like, this one would be BGR, and then that one is something else. That's ground. That's ground. Doot, doot, doot. Huh, they have different identities. I'm gonna have to rename some stuff. Razer came out with light-based ones with a photodiode and an IR LED. For the mouse? That's interesting. Hall effect key switches are interesting. Yeah, I agree. It's a lot to be putting into a keyboard, but to be able to match walking speeds in a game, it would be very nice. That would be the only real purpose of them, though, and it wouldn't be all that comprehensive. I mean, you might as well just reach for a controller at that point. You know, games like GTA 5, where you could just grab a controller and use that, and then flip back over to the keyboard. I love that. My friend hates controllers so much that he almost will never use one, whereas I flip back and forth because they have their purpose. Controllers are very good at your analog inputs. I hold no qualms in that regard. One thing I don't want to do is damage these, so I gotta be careful when I'm poking in on these wires. Kilo ohms. I need the microscope for this because these are genuinely very small. Well, that one's a white wire. That's not that one. Where does the white wire go? Oh, it goes to the other side. What does it? What is it? Huh. Okay, that's that one. So that's the 1, 2, 3, 4, 5. Bottom one there is pin 5. Oh God. Okay, hold on. We gotta figure this out. All right, so let's figure out which ones are going where, because this whole area is a little bit confusing to me. There are a couple of these that have transistors associated with them, and I don't think they are doing what I think they're doing. I could check the functionality in my drawings, I guess. I just don't know. There's 3 of these transistors. Is that going to be for this backlight and then these other 2? Or is this 2 pins of that going into 1? That's not how it is. That's not how it is. And this is in 4.7. On mine, it is 1K and then a 3904. So where is that going? It's coming from multiple places, and that's certainly not what I have on my board. This is what's on their board. We needed to take better notes on this thing, is what happened. That's what kind of happened to this. I needed to take better notes. Because yes, some of these pins are going up to, and let's actually clock it on the old board too. Let's make sure we know what's what. So we know what is what, but we don't know what is what. We just strut. What the buck? So over here on the old board, we've got our 2, we got a little bit of schmutz. We have our 2 transistors that are going to the positives, and maybe that's where my transistor circuit comes in. Maybe that's why I'm unable to control it. But this is coming in from here, so I'm going to go here and check. Oh, my multimeter is off camera. So from here to one of these. Oh, I think I slipped. 11K. Well, that means that it's going here. No, that's 10K. So we are going into this. It's just through a resistor of some kind. Are these two connected? It looks like they are. Kind of looks like it. No, they're not. 20K between them. So let's see. Up here we've got that resistor. Maybe we're coming in here, and this is positive. Where am I? And this is which one's num and which one's, I guess they're not identified as being one or the other. Num and scroll and caps lock. I can make them do whatever I want. So if we look here, it's through 10K. So if it's through a 10K, that probably means that I can go here and get nothing. Good day to you, sir. No? What about here? Usually that's the one that's controlling it, isn't it? Trying to just identify, because this is num and scroll lock, and then the other ones here do the RG and B lines of the num and scroll lock. And then somewhere around here, one of them goes to the transistor that controls the backlighting. So there's 3, 4, 5 connections, and then we have another connection that goes to the backlight. I need to figure out where that is controlled from. That's 11K on that. Why is it 11K? 10K? Why am I not getting 0K? 11K. Something weird. That one goes directly to the diode. So there to there. Does one of these go to 5 volts? Let's check that. No, this test point is 5 volts. 10K. Is this going to be 0? Yeah. So that's 5 volts right there. So we've got 5 volts coming down through a resistor, and then we have the transistor switching it to the LED. And then this is probably not ground, is it? Let's check ground on this. Where's ground? Looking for a ground. Let's find a ground pin. So power test pad, here's ground, these two. So just grab this one. I wouldn't think it would mess with ground. Yeah, it doesn't. Okay. So is that our signal in? That might be our signal in. Which would mean this pin here is what we're looking for. The other one is power. So if we're looking for that pin, and I go to here, 10K, here, 10K, maybe one of these others. Oh, there it is, ohms. Okay, so 3 pins up, and we go to our Q203, which is on, I don't know which one's going to be which. One's scroll lock and the other is caps lock. So I guess we'll call this one inboard and outboard. Why not? So on Fusion, I'm going to document this. I'm going to go down here, show you guys what I'm doing. So this one, if I'm correct, it's 4 pins up is the inboard positive. So I'll go to, actually not this tool, I'm going to hit N for name, and I can name the trace. In plus, in positive. Well, in looks a little bit too, so I'll just do right and left. So I'll do N for name, L RGB positive. The underscores unfortunately interfere with the thing, but then again, I'm not publishing this. So the N tool again, and this one is R RGB positive. All of this is an effort to avoid and eliminate confusion. That's the whole purpose of what I'm doing here. The PlayStation controller actually does a fairly interesting way of doing analog. What they have is they have a pad that's a resistor. And so on one side of the pad to the other side of the pad, you have a certain amount of resistance. In order to make that into a potentiometer, what they do is they have conductive rubber in, well, it's convex rubber. And when you push down on it with a little bit of force, it'll make a small dot in the middle of that resistor. What that does is it provides a non-resistive path from one part of the resistor to the other. So it has a little bit less resistance. The more you press down, the more of that contact patch gets into the middle of your conductive exposed resistor. And so you're shorting out the resistor as you press down on that button more. And so the resistance can be translated into a voltage, and you get a variable voltage out of that. Very cool way to do it. It's a very interesting way to do it. PS controllers use the flexi PCBs. Yeah, the flexi PCBs, I don't know why they use them so much. I think maybe just cost at scale is probably one of the things, because you have less material going into that. I need to sneak my window shut a little bit. It's getting cold. I'm getting cold. It's a little frigid out there, much like our hearts. Oh, wait, caught. Ugh, cables all over everything. All right, so I need to figure out what the rest of this crap does. I can't believe that numlock and scroll lock LEDs are on one thing and everything else is on the other. It's so weird. It's a very weird design. The what? Okay, so our left and right RGB positive is over there. The negatives are going to be over here. And let's just see what we've got. So all of these are connected. You can see they're connected. They're cross-connected with each other. They have a positive input that gets activated, and then these go to, I believe they actually go to, oh no, these go to the microcontroller. Right. This keyboard likes to use rows and columns for everything. But if I go to one of the LEDs, I can come over here and likely find it right here. And it's this one. And it's this one. And it's this one. Easy peasy. So that's all internal, so we don't have to do much with that. We just know that pin are our RGB. And I've already got that mapped out. I think, don't I? Did I map this out? Oh, I didn't really map it out all that well. So what we can do is we can use the multimeter in order to tell us which one is which. We go over to diode mode, and now I have a positive and negative, and I can just tap into the LED, and seeing it is going to be the problem here. But if I tap the positive and negative into the LED, I can just see which one is which. So I go to the positive with this. Positive is the second to last one. I think it's BR space G. We're going to use the camera to help me do this. We're going to use the camera to help this process out. Where are we looking? We're looking right there. Positive. Here. Blue, green, space, and then, oh, no, that's dot. Wait. Blue, green, red. There we go. Okay, so blue, green, red from the left. Blue, green, red. It's blue, green, positive, red. So now I get to see which ones connect down here. And I think the bottom one was blue. All the way down here. This one was blue. Oh, I need to go directly to the pin. Blue. Logically, this one would then be green. Okay, so it's blue, green, red. So here we can go on pins. Oh God, what were the pins? 3 pins up. And then here, doot, doot, doot. So this would be, name that one RGB. It goes to both. Red, RGBR, RGBG, RGBB. All this to run the 2 LEDs that I haven't even programmed into QMK yet. You know, it's not fair. RBG just like that, and then the positives I have, I believe they're flipping, but there's another flip in there. I had to take a call. What I missed, just some light reverse engineering. Light reverse engineering. Not like reverse engineering light waves, but like, you know, just casual reverse engineering. There we go. That's the one. That's the ticket. These are also going to LEDs. And they, I think, are the 2 that I flipped. Why is there a 3rd one that I flipped? I don't know why. I heard QMK. Yeah, we're doing a QMK takeover, but we're not just reprogramming the Sonics chip. We are taking it out, and I'm replacing it with a flexi PCB. Oh, wow, there's reverse engineering light. We're going to have to make light better. We need to make light a little bit more obfuscated so it'll confuse oh bother. I believe these are controlling the backlight. I don't know if they're both controlling the backlight. If I go from one of these, because I think these are MOSFETs. If I go from one of these to our LEDs, which would be the things that the resistors are on. So this right here with the 168 ohm. I go down to here. I get 0.6 ohms. So that's one bank of the LEDs. I don't know what this one's doing. But that is what pin? Oh God. Pin 1, 2, 3. Stupid. Anyway, I think that's a pull up. We're going down there. So what did I do on the keyboard that I modified? I have the white wire going into that pin, and then I don't do anything with the other one because I'm scared of it. Actually, no, I think I'm shorting them together. Yeah, I'm shorting the 2 pins together. Okay, so that's what that 3rd one is. And that goes to the pins on the main controller. Where is that one? So that's, oh, I see. I've got BL1 and 2 on this thing. And I guess BL1 and 2 are getting shorted together, and then they get a transistor circuit to flip it. And then that goes to pins, these guys. So that one's backlight all the way up here. Backlight, and these are the 2 positives for the RGBs, and then these are the negatives for the RGBs coming back through. I guess the negatives have their own transistors already. It's just I added these to flip the bit or something. I don't know. Or to make it so that it didn't blow up the microcontroller. I thought that would be easier. Well, it's not. I don't know. Reprogramming the Sonics chip is probably just a matter of getting something QMK compatible to like a bootloader or something running on it, right? There are people who are working on it, I think, is what I gathered. Short Lurker knows the link. That was in here yesterday, or last stream, rather. All right, so let's get cooking with this thing. What was, oh, that was not on this one. It was backlight 1 and 2 are on there. And then this is all of the, see, the reason that this thing takes over the RGB lights is those RGB lights are used for troubleshooting. So if something goes wrong with the main Sonex microcontroller, you can do a factory reset with this second microcontroller. It will program this one. Weird. It's a weird kind of backup method. But then what happened is, instead of something going wrong with this microcontroller and having the second one be useful for recovery, the entire complicated system just fucking died when I spilled stuff on it. So useless, totally useless and stupid, but whatever, to each their own. All right, so up here on this one, I guess I've got a couple transistors. I can just do the circuits on their own. Let's just do the circuits in their own little spot. So we're gonna have 3 transistor circuits here. So now I need to actually go to parts, and I need to choose what parts I'm doing. So place components, and then we're gonna get a, well, 1N4148 would be great, but that's not necessarily, it's just, we wanna do components. The components managed, it's my library, it's the library that I curate, I keep it together, I have 3D models for everything that I use, and we're gonna put in an LM3904 transistor. So an NPN transistor, that one doesn't have a thing on it. So do we have an actual, I think I've got a regular old MOSFET N, MOSFET P, PTC, resistor, SMD, momentary switch, transistor PN, NPN, and PNP, huh? I don't have, well, I've got MOSFETs in here, but that's not, yeah, I've got weird MOSFETs. Oh man, we're gonna have to make a part. It always comes down to this. Listen, Fusion 360 is Eagle. Eagle didn't have the best parts creation in the world. I've gotten very familiar with it. It is unfortunately where you're going to be spending a lot of your time if you use Fusion 360. You're going to spend a lot of time in parts creation. They're probably working on it. Hopefully they're improving it. You basically think of the part as a tree. It is a footprint. With the footprint, you associate a package, and that package gets a 3D model. That's essentially the hierarchy of how it should be done. There are 1,001 ways to get into that. What I'm going to do today is just make a part going from one end to the other. And that should hopefully make things a little bit uncomplicated. We already have a footprint. We already have a schematic symbol in here. So all I need to do is add a 3D part to this thing. And the transistors we're using are which kind? They are NPNs. I think that's what the 3904 is. I really don't have a 3D model for this thing. Oh no, they're NPN. Which, what does that mean? Does that mean positive, active, whatever? So we need a model here. So we're going to right-click it. I'm going to go to Open in Library Manager, and we're going to find a generic NPN transistor data sheet so that I can get the mechanical properties. So 3904 data chart. 3904 NPN silicon blah 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 SMD. Need it to be SMD. So the MMB 3904 is just fine for us. Look at that little guy. And then what I will do is I will go all the way down to the mechanical section. Down we go, down, 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 all the way down to the mechanical section. And here are the numbers that we need. Now there's probably a generic 3904, or sorry, generic SOT 23. Damn, what is the name of this thing? Wow, this is early enough that they don't really name it at all. It's weird. Okay, well, and anyway, we're just going to take these measurements and put them into our CAD program, and it will auto-generate a 3D model for us. Why did this? Oh, well, what I'm doing is the components managed, and I want the one with the highest version number. So version 73 is also in use, so that's the one that we're going to edit. I need to clean this stuff up. There's a fork of QMK for the Sonex chip. I'm in those guys' Discord, but it's incredibly complicated, or at least to me it is. Yeah, I would assume so. I mean, I could try to use it on this, but I don't know what the water damage did to it. So transistor NPN, we've got a little tree here. It's got the SOT23, then it's got, oh, wait, we actually do have that in there. That's the NPN. Wait, so I don't have to do anything. What do the PNP have? That is a model too. Why wasn't it showing up in the... This should be the latest version of the model. Hold on, let's, oh wait, no, we're going here. And I'm going to paste components. And it's going to be npn so, and then it says there's no 3D model. What the hell? Same for that one. Why would it say that? I hate the value thing on these, with the value like spilling out. But why isn't it showing the 3D model? Maybe it just didn't update the 3D model. Let's update. Check for updates. Broken 3D model. What the hell? Well, there's definitely a 3D model associated with it because I'm seeing it right here. There he is. It's right there. Footprint in the document updated with... Okay, well, whatever. It's here. Here it is. Finish. Is that going to, like, register it as an... Oh, God, what's all this stuff? I have a lot of components in here, don't I? A lot of 3D models of components. Open up that and check on it. Look at you. Yep, it updated. Finished. I guess because I changed some stuff, it had to change those. So does that mean that if I manage and I upload, okay, create the new library, it'll download the library, everything will sync up? It should be more like Google, where you just kind of do stuff and it updates on the server. Seeing the speeds that we're getting, though, that would be supremely annoying if every single step of the way I had lag. Okay. We're doing stuff. We're definitely... this is worrying. Oh, there it goes. Okay, phew. So if I go back to... Oh, yeah, user save, blah, blah, blah. I go back to here, and if I update all of my libraries... Whoa. Package variant is not present. DIP12 placeholder. What? All right, let's just hit cancel. Let me just wait. Libraries, update them all. What's going on here? Holy crap. Is this going to mess stuff up? Better not mess stuff up. Package variant is not present in the new version of device set. DIP12 placeholder. Please select a new package variant. No, I'm going to hit cancel. I'm going to go back over to here. See, these are components, so the DIP12 does not, it's not part of this one. Why would it not be? I guess, Yeah, that's this one. But it says the package doesn't exist, but I've uploaded this one already. So it's possible that between my two machines, even though I saved and uploaded everything, it seems to not think that this exists in the library. Oh, and maybe because I didn't update and then I did that little edit. No, but I didn't even edit that library today. Wait a minute. I didn't mess with that one at all. I was thinking things are like out of sync. Let's download from the internet. Library is up to date. Okay. That's specifically for updating some library. This is DIP12 is not represented. But that's this. Oh, maybe I just have to associate them. Yeah, that's my drippy variant. Okay, whatever. One update from the library on the board. So we go over to the board, and that's going to update all that stuff. Luckily, it stays in the same spot because that's a very careful measurement. And there's one of the transistors that I was able to get down. And then if I put that in here, we will then probably be able to jump to the 3D design and actually see it there. But let's get the rest of these in here. That's weird. I mean, there was always a 3D model associated with it. It just I don't know why it didn't, it didn't trust it. All right, so 3 transistors, and they are connected to ground, and they have a 1K resistor. And then these go to, or no, it's here they go to the microcontroller. Let's get the resistor down. So library, place components rather. We're in component manager, and we just go to resistor, resistor, crystal diode, fuse. There it is, resistor. Now, what size? I think I'm going to go with 0603, just because that's a generically small resistor. It's within my comfort zone of soldering. 0805 is probably preferable, but what microcontroller? Well, it's going to be an RP2040 on a Pico Pi. So it's a Pico Pi with an RP2040. I'm using the whole like module because I don't feel like designing a voltage regulator, and I don't feel like designing putting a crystal on the board and stuff like that. So I'm just going to use the Pico Pi module instead of an RP2040 chip. I would save a lot of room if I did the RP2040, but it would be a pain in the ass to solder. So I'm doing it this way because it's quick. Duplicate those grounds. Bonk. Bonk. This one's too close. Bonk. And let's just spread this out a little bit. Boop. And then we're going to need a little bit more room around this. I'll just scooch it forward a little bit. And we're using the crutch of signal flags. We're going to put signal flags on this, and that makes our design a little bit easier, but it also just makes it annoying. It makes it so you have to reference stuff constantly. And I definitely don't need this here. Trying to be helpful by giving you the value, but what it does is it just makes your schematic too busy. Okay, so one of these is going to be coming from backlight enable, so pin 32. Let's make this one BLN. Oops, wait, name tool, letter N, click on that, BL enable, backlight enable. Yes, I would like to associate those with one another, backlight enable. 1, 2, 3, where does this one go? This one goes to, oh, it goes to the microcontroller, right. BL enable is coming from the Raspberry Pi Pico, but then it goes to something on the Sonics chip. And I need to find out which one that is. It's BL1 and BL2. So it's actually both of these at once. Oh, hold on. How do I make that junction happen? Well, I guess I'll just call them BL. Nope. Yes, to connecting them. Okay, so we'll just do that. Which is a weird way of doing it, but whatever. Actually, yeah, what I need to do is just get rid of this one and then have this over here. That communicates 2 lines into one a little bit better. Backlight there, and then this one goes to BL. So name this one BL. Okay, so BL enable goes through the 1K resistor, and then it goes to the gate of the NPN where it connects the backlight pin to ground, which I believe it already has a pull down to ground. Oh god, it's a huge mess over here. Oh, I see. Yeah, so I desoldered the capacitors and stuff. So I'll have to do that on the new one too, because those have a pull up on the pin. I will be pulling them down. Wait, what? I guess that's what works. I guess that's whatever I have works. I don't know what I did. So that's backlight enable. This one goes to, what is it? LRGB and L left RGB power, right RGB power. Jeez. So, oops, wait, cancel and name. Gotta use the name tool. LRGBP. Yes, that's that one. Wait, that's the wrong way, isn't it? Yeah, it's the wrong way. We're going from the other side. LRGBP. LICUP. RRGB power. Those are enabling those to have whatever signal there. Okay, and then we're coming from which pins? Oh, num and caps lock and num. Caps lock and num. So which one does 29 go to? How am I going to figure this out? One of these goes around, it goes to the transistor circuit, and it goes around to one of these, and the lower one is the left one, I believe. I think the lower one's the left one. We measured this before. How do we do this? Wait a minute. NPN with a gate drain source instead of a... Yeah, I don't know. I think that held over from my... I used the same... I think I used the same schematic on it or something. I copied something badly and it put that in there. I can correct it some other time. These have gate drain and source. So it's whatever the bottom one here. Oh wait, that's RGB. No. What am I looking at? Looking at these. Which one is num and which one is caps? So which one's the left one and which one's the one on the right? Which one are you? Show yourself. These have, is that a pull up? I think it is. Yeah, because I guess this is power for whatever programmer they're using. Let's pull up 11. The drain. 11K. All right, I need to see what I'm poking. 11K, and this one should probably be. Why are they both 11K? Throw me off. 10K? What the hell? It's like 11 or 10K. That's all I can get on these pins. Oh, is that because it's down here? Yeah, it's down here. So 1, 2, pin 3. And then is this one? I got to make sure that I get the right pins on this thing. Okay, so this pin is the left side. And then the pin below it is the right. And it's 1, 2, pin, pin. Oh, and I got that right. Okay. So, LRGB power for those two, and that's what's coming out from our thing. And so when I wired it, which one did I do to which? I just want to get it consistent with this because this is my test bed. So in order to do the lower one, magnet on my multimeter is attaching itself to the keyboard. So the lower one here goes to which one of these? Okay, the higher pin number. Lower one goes to the higher pin number. So then, where are these two? They're connected somewhere up here. So, lower one to the, actually lower one to the lower pin number. No. Oh God, what am I doing? What am I doing? Yeah, so this top one goes to the lower, which is right RGB. So right RGB goes to NCC. There we go. NCC. It's a lot of cross-referencing stuff. Wait a minute, make sure I get that right. Why are you thinking? NCC. Disconnect, put that there. And this is NCN. There we go. All right, so that's those. What display module? Just a generic OLED display. It's the cheap one. It's the little I2C LCD. I have a button. Take a cat. Hey, Silly Russell, thank you for subbing. That's .np4. I don't know if I trust that. What in the world? It looks like a human organ. We removed this from some guy's body. That is a little kitty. Okay, what probes are you using? So these are the Fluke probes, but I have high voltage caps on them. And the high voltage caps are supposed to remove you from the action so you don't shock yourself. But what they allow me to have is an extremely sharp, pointy tip. So those pointy tips will break through a solder mask layer. If you poke this down, put a little pressure into it, and like twist, it'll actually break through the solder mask, and I'll be able to get a connection here. I don't want to bend them too much. Oh, they got a nice solder mask on this. Yeah, oh, okay. I guess I'm wrong. They're good at poking through oxidation too. I think these have gotten a little bit dull. But they also are good at extracting blood when you clip them to the back of this thing. You're gonna have to explain that one to me. So yeah, I've done all of this work to wire up my own Pico Pi to the keyboard, to the CODE Tenkeyless. CODE Tenkeyless messes with the rows and columns of this thing. Oh, him, yeah, the unibrow guy. Boy, Twitch is weird. I'm just some guy, right? I'm just some guy who decided to have a pretty consistent Twitch stream where I do electronics with y'all, and we kind of get into the stuff that they don't really show on YouTube. But like big name YouTubers have actually found their way into my stream. We were incommunicado with Strange Parts for a little while, which was really neat. It's like, oh, you're the guy on Twitch that does electronics. It's like, whoa, you know who I am? Like, it's kind of crazy. I'm just some dude. But yeah, it's 128 by 64. That's the common SSD 1306. Yep, that is the one. You need to shock yourself more often. No. I wear medical equipment. Type 1 diabetic. I'm a type 1 diabetic. I wear an insulin pump. That's a little piece of electronics, $30 piece of electronics. I wear a constant glucose monitor, which is a little piece of electronics. Those two together are extremely expensive. And so, no, I will not do anything with high voltage and shocking myself. I don't do that kind of stuff here. We don't do that because if you follow even a modicum of safety procedures, even the lowest level of safety procedures, you should not be shocking yourself unless it's static electricity, right? We don't even wear a static band. I don't have a wireless static bracelet on because we don't need it. You don't need it. You just touch something that's metal, make sure you discharge, and you should almost never static electricity your electronics. But like even the lowest level of safety procedures, use the one-hand rule around high voltage and stuff like that, we get by pretty well. I have one viral clip, and that's of a capacitor exploding, which is kind of dangerous in and of itself. I was finding little bits of cardboard everywhere. Mains will kick your ass. It mostly makes you like, why is this pain? You feel pain. At least here in the States, it's pain. Mains just represents a sudden influx of pain. You're like, why? If it's not across your heart, which it should never be. That's what the one-hand rule is all about. Okay, so I think we have everything represented except for the reset button. That's what the DIP 12 placeholder is for. Now, if I want to, I could extend the 2D PCB all the way over and have that there, but I don't think that's a good idea. I would rather not include the DIP socket at all. I could do a modification that looks like this, and then I could have a singular pin coming off of it. I would rather have something that I could drop into this location. I think the reason that I did it this way was that we had access to ground through these pins, but we did not have like a button thing that I could use. I don't know. Why did we do it this way? Be a good spot for like a reinforcement. Can't do reinforcements with the Eagle though. Oh, and I can't get to the other side of the board to desolder this. That's a weird one. I may have to just clip off the legs of this thing. Groovy! Celia Russell is gifting a sub to Groovy Some. That's 112 gifts. Celia, thank you so much. I cannot thank you enough for being a gifter all throughout time. Was it a random or was it targeted? I think it was targeted. Gifting one tier 1 sub. No, it was random. Well, Groove got sniped. Yeah, that's great. Good on ya. Oh, and then the Leb TV re-up. Leb TV Live. Gift sub by Celia Russell. Going back 1,000 years. Thank you. It means a lot. So I could drop in on these diodes and they would give me access to... Well, this board is dead, so we might as well just desolder this thing. I grabbed a pump with 2 hands and felt no pain. Just a nice clean current from hand to hand. Actually, helped me do something stupid later. Help me do something stupid later. We had a water leak in our physics lab. Everybody leave now. Holy shit. Yeah, ground loops and stuff like that, you know, messing around with high voltage. Not something that I really like to do. You know, you see those GIFs. We saw a GIF the other day where somebody was plugging stuff into the back of the computer and it made a huge spark. I don't mess with high voltage. I wear medical equipment. I can't even sweat. You know, if I get like if I'm wrenching bolts, I'm turning those bolts, I end up sweating a lot, and you can be in danger of shedding your adhesive medical appliances. Adhesive medical strips. What I'm going to do is I'm going to get solder on the top of the board here, and then we'll use hot air to extract this thing. Hopefully without melting it. Not that we need to rescue this in any way. I just want to get it out clean for no reason. Leb should have the first thing too. I know, but it's like, I don't know. We could count Leb as being like the bot account for the channel, and I could just gift him a permanent sub. I still haven't identified a bot. I don't know. Maybe one day we'll need it for a bot. But like Leb really should have that first thing. It's just I don't think they anticipated that a user would be like a routine gift. Yeah, hot air. It's nice to have. It is a crutch. You don't necessarily need it for everything. If you're going to get into QFN packages, you kind of should have it to do the heatsink pad. But otherwise, you know, if you're troubleshooting or you're developing on like QFN packages, you can just get to the pins that are under the chip. I happen to have a QFN just sitting here. You can just dead bug these in order to develop with them. And then all you're missing out on is that center pad. You can use a skillet to do that as well. You can use a soldering iron just to get the edge pins and not the heatsink. But hot air ultimately is probably the best way to be working with stuff like that. Yeah, and then the small pitch ICs. This is going to be kind of a nightmare. Well, let's try it. Let's try it. Hopefully we don't burn the thing. I'll get a little bit more flux on the board just to give us a fighting chance. You know, the classic way to get rid of ICs, to get them off of the board, is if you're developing with through-hole ICs, you just clip it off. You just break the IC and get another one out of the cabinet. The skillets are getting cheap, and I bought one of those cheapo skillets. Maybe one day we'll be able to use it on something. A clothing iron? I guess so. I actually have seen a setup that had a clothing iron with its own like regulator in order to make sure that it got hot enough. I probably want the long tweezers for this. Actually, forceps. Forceps are stainless steel, so I can actually grab this thing without hurting myself. I can heat up this end, and it'll, by the time it gets to my hands, it's cool. This is really where thermal imagery comes in handy. This is set to 500 degrees and a low flow rate. .203 Fahrenheit melt point solder. Yeah, that's what I call chip quick. I use something called chip quick in those instances. I kind of want to spread heat around too. I don't want to overdo it in one area, but I don't want to melt any switches. Switches get stitches. And 500 degrees can eventually harm the board, so we just got to be careful about that. My soldering iron is set to 666, although the iron itself actually dumbs that down and makes it 650, which I don't appreciate. I want to keep my number in there. This is 500C though. This'll mess up your Christmas. All right, let's put the stink into it. Ah! Now we broke it. All right, well, it melted. It melted. Game over, man. Screw that. Well, actually, let's keep the heat on it. I can get it off with tweezers. I tried. Chip Quick is quite useful. Oh God, all right. Now, instead of making everything smell like plastic, we're just gonna cut this. We just gotta cut this out. Yeah, this is kind of a sensitive part. The plastic in it is rather cheap, and it's a mechanical thing, so it's not the typical epoxy IC. An epoxy IC would have stood that just fine. It would have been fine with it, but this one clearly is not. So what we can do, I mean, if the plastic is ruined enough, I could probably just pluck the different pins out of it, but I can cut this carefully, because remember, when you're cutting it, you're also flexing that metal all around. But I can carefully cut the pins of the IC off, and then I can just take them off individually. That's where the Nipex come in handy. I don't want to, that thing's still hot as hell. I mean, I have one of the solder sucker guns. It's pretty good for this kind of stuff, but I don't think it would have helped us here because I can't get to the other side of the board. I just can't get there. I don't have it. Metal fatigue, metal fatigue. There you go. So now we just carefully, one by one, extract these. I gotta move all my other circuit stuff out of the way. Get out of the way. One of these days, I'm going to take a whole bunch of ADHD meds and get to programming my module testing module and give it like a menu system and everything. That's one of those low dopamine tasks that I desperately need drugs for. Drugs turn me into a normal, functioning human being who has goals and tasks. This isn't gripping at all. I need something that's going to grip it a little bit. I'll use the forceps again. Oh, that's right. Yeah, I remember your chip programming setup. I would imagine the rework can be pretty stressful. Look at how, why are the jaws are like way off. Terrible. We should actually, the beauty tweezers are going to be the ones that will probably do the best for this. Yeah, you know, you got to pick your battles with this stuff. And in this case, this is totally acceptable, this kind of damage. What is my goal? We're making a flexible PCB that's going to lay over top of this circuit. These are beauty tweezers, so they've got a little bit more pull at the tip. You can see how they kind of taper inwards for like hair extraction. So these will enable me to hold on to this a little better in close proximity to the tweezers, or to the soldering iron rather. But I've got to make sure I put in enough heat that it gets all the way through. The goal here is we're making a takeover circuit. So we are taking over the function of running a keyboard from, what do you call it? From the Sonex microcontroller that was in the CODE Tenkeyless keyboard. I should be going the other way. This is much easier to get the tweezers in like this. So we're doing a code takeover, or a brain takeover basically, and we're putting an RP2040 into this circuit so that I can run QMK. Now, I've already done this. I've already done this with my other keyboard. It's time to clean it up now that we know everything that's going on. And it works, and it's worked for some time now. I've had the keyboard for a couple years now. For a year, I think, is when we did it. Maybe 2 years, actually, to be fair. But what's going on here is I'm getting rid of the dip switch because I don't have all the configurations in QMK are done with software instead of telling, you know, your microcontroller that you have some kind of a different, like, oh, I'm plugging into an Apple now. The way that I would do that is by fully reprogramming the microcontroller and saying, hey, you're an Apple device now. So I don't need this dip switch. I don't need it to do anything. So I'm removing it, but the dip switch also has a hole in the back of the keyboard case. And so taking advantage of that, I can have the reprogramming button in this location where it's out of the way and it's accessible outside of the keyboard. So I just give it a little reach around, and then I can reprogram it. So I'm getting the dip switch out of there. I tried to do it clean. I tried to do it their way. They weren't having it. I think the solder sucker is needed here because that pin fell in. It's currently hanging out below. If I'm lucky, I can extract it by sucking it straight out. Did I get it? Nope. There's a local like car place around here, and their slogan is possibly the weakest thing I've ever heard. It's boy, I guess. How do you make, you know, go to Blobbity Blah's car purchasing thing, whatever, used car lot, and buy the best in America, boy, I guess. It's like the most unsure of itself thing. Oh, it's terrible. I mean, I guess I can poke it through and hopefully it'll come out. So what I need is a pin tool. I seldomly use this pin tool. We need to flatten the pin tool. Pin tool's in bad shape. Look at that pin tool. This thing has seen some brighter Mondays than this one. Let's flatten this out with a pair of pliers. I, I have one, but it's just I don't want to get it. It's fine. The pump's not really going to do me any favors here, because what I'm trying to do is get a pin out of this. Just removing the solder is not going to bring with it the pin. You guys know that I'm an expert in soldering, right? You guys know that? Like, if there are certifications to be gotten in soldering, I could get them today. With ease. We have thinner pin tool. This one will do. Adding solder is just going to make it drip on the underside, but I guess I do kind of want it to drip out. There's a big metal plate on the other side of this, so I can't get to the other side. There we go. So now I can tilt this and get my pin out of here. Well, that's going to be somewhere very internal and very unreachable. Interesting. The flux is probably sticking it to the side, so I guess we'll never see that pin again. It would look like this, but without the flat spot on it. Oh well, that one's gone. Let's see if we can get the other one. Z. So I'm not desoldering right now, I'm depinning, because these cut kind of close. I don't want them to fall through. That's the worst case scenario. Yep. You got to wait a little bit for the heat to get all the way to the other side of the pad. Hopefully it doesn't short something. I don't think it can. The components are all on this side of the board. The other side is just used for routing. I don't think I got it. I think that still has a pin in there. The other ones were nice and easy because they severed right at the IC. These didn't. They've got a little bit sticking up. You got a lot of this other solder in here too. Come on now. Is that it? I don't think that was it. I think that was just solder. Yeah, that was just solder. I might have lost another one. Let's solder suck that and see what happens. Ask away. Ask questions. I'm good for questions. Hopefully I won't give you a rude answer. What is going on? This thing is plugged by the pin, I think. And so, like, you know, what I'm expecting to see is this. If I put the iron over the solder and then I suck on it, it should, oh, that actually filled. It should look like this one. It should be like a blank hole. I don't know what the hell solder they were using on this thing. Not incredibly important. Yeah, the dip switch is represented by one row and then a bunch of columns. And it gets scanned when the keyboard boots up. We don't need it. All I need is access to the pins so I can run a tactile button. Hairs in my eyes. Ah. Yeah, I gotta get a haircut soon. when I pinch it with the tweezers, it's actually cooling off the solder that's there. And so I'm losing all the heat that I've got on that pin. Backseating. I don't know. When I did this, I think I got ahead of the backseaters by just doing all of the wiring stuff myself. And then everybody saw how skilled the wiring was. It was like an ooh-ah moment. I am having the worst time getting heat into this thing. I don't know why it's fighting me the way it is. Maybe just that the tweezers are sucking all the heat out. Or it could be that the solder is a different solder than what I'm used to. That or the pins sticking down through the board is acting like a big heat sink. Yeah, that's what it is. It's just acting like a big heat sink. Come on, there we go. I don't think ground plane is involved. We do have this, which could be sucking away a little bit, but I think it's mostly the tip of the tweezers. The stainless steel will suck your heat out and then dissipate it like in a small area. Stainless steel is very frustrating. What's up, Make Mistakes? How you doing? It just takes a lot of time. Weird. Oh, that didn't even get it. I mean, I could also employ the big soldering iron. That may be the direction I need to go with this. There we go. A lot more trouble than it was worth. We need to map out where these go on the microcontroller because we might be able to do a takeover of the pin. And I may be able to have this actually work like a regular button. If we can send ground into one of the pins without interrupting a whole row or column, that's the question here, is that where is this dip switch in terms of rows and columns? What the hell? Let me, oh my God. Okay, I'm switching iron tips for this last one. Too close for missiles. It's not really wedged. It's just that all the heat that I'm putting into it is going away immediately. So use big iron, and now I'm not asking. I'm telling you that we are removing this pin. Needs a little bit of heat over time. That one just twisted. Getting it twisted. There we go. I had to lift straight up in order to extract it. Now this is the one that was all weird, right? Is there anything in there? Doesn't look like it. No, there's nothing. Okay, so let's get the solder out of here now. I could use wick for this. That would probably be the best, but that also does a pretty good job, though. That looks brand new. Well, wick does the best job, but you can tell by how not glossy this is that there's a lot of lead-free solder in here. I know, it gets stuck in my head constantly when I talk about the big iron. With the big iron on his tip. Big iron on his tip. Everybody's playing New Vegas again, huh? I did a Fallout 4 playthrough, but once again, I got completely stuck with the building mechanic. It's just too addictive. I think I'm going to try Obensour next, because that looks like a pretty fun game. Brabos has been playing it. But yeah, it looks like there's a piece of a pin stuck here. That could be an entire pin sticking through. So let me just make sure that this is the one that we tried to push through. I don't want to go too hard into the paint with that, but that may have actually loosed the final pin. Hopefully it didn't lay flat. Yep, there it is. Ha-ha! We got him! Ladies and gentlemen, we got him. That was the pin that I was trying to not have fall into the electronics. So, beauty. Now the hole looks clean. Looks like a nice little avocado. Yeah, that was a happy accident is what that was. Oop, didn't get it fully. What's up, Tim? Yeah, I guess my playthrough is perfectly valid. I just didn't get very far in the plot, and I probably should have. I should do like the Brotherhood of Steel stuff and stuff in Fallout 4 because those are apparently a lot of fun. But again, once again, I just get out of the vault and I end up doing everything in service of building a town. And there were some good mods that could make it so that your townspeople were a little bit more independent. They didn't just like wander around. They actually like gathered stuff and made personal space and utilized, you know, all of the, what you would call crimscrams, all the little details that you put into building their city. I played it fairly vanilla in that regard, and I put a lot of hours into it. Boy, oh boy, is it fun to do, you know, to build a little town. But in the end, you're like, it's kind of lifeless. It's kind of lifeless. And I never got to the plot, which apparently is good because the plot is terrible, from what I hear in Fallout 4. Man, this is tedious. We're cleaning up this dip switch because we need to invent a way to take over it without making our circuit too big. And when we figure that out, that's everything. That means that we've figured everything out for this schematic, and we can move on to the physical design. We can start putting down traces and setting up the edges of our circuit board and whatnot. Okay, so that's clean. Let's go back over to here. Now, ideally, we would have traces that only go to this dip switch, and we can somehow get a ground and a power to, what do you call it? To a tactile button. Let me get a tactile button and see if we can actually fit one into these pins. And then we'll do a little bit of ohming out and see if we can figure out how to plug it in. Here we go. Tactile buttons. Always have these on hand. These things are so useful. You can buy them cheap. They're cheap. Just a little package from Amazon. Cheap, cheap, cheap. They're so, so useful. Since this is a dip socket, this plays into the standardizations of electronics, the inch standardization, because America invented everything that's worth anything, right? You know, we invented everything. And so we invented the English system of measurements, which we used in electronics, which we also invented. Nobody had any other hand in this kind of stuff. And so a dip switch and a tactile button should be able to commingulate. I guess there's a little bit of a extra distance there, but it'd be nice if I could just solder that down into that package and it would work. Yes, this silicone, this is the Engineer. Is this the SSO2? I forget. The label is long since worn away. There was, by the way, when you buy this, look for the Star Trek The Next Generation font. That's what the font should say, Engineer SSO2 solder sucker. Then, when you buy more rubber for the tip, what you need to buy an SS02, 1/4 inch or I believe 4 millimeter clear silicon rubber hose. Silicon rubber will stand the heat of the soldering iron, and it'll make a nice little seal around the tip. This thing also has a little nub that will help extract the solder. So what you do is you put your generic clear tube over the little end here, extend the little wangulator, and then cut. And so then you have a perfectly extracting thing of solder. Now eventually this will fill up with particles and bullshit. Take it apart, paper towels and gloves. You don't want to get any of the solder little things all over you because it's a lot of lead and chemicals. So take you know, paper towel, clean everything out 100%. You can also buy O-rings, generic O-rings to reseal some of this. Like this is getting a little crusty after a couple years of use. But what you do is you take it all apart and then put it all back together, you can just use dielectric grease in this thing. You know, you can use any number of greases on it. The dielectric grease works perfectly for me. I got a big container of dielectric grease and I have nothing to use it on. So that works perfectly in this thing. You just slather up all the internals and it's like new. So you can fully refurbish this. This is a forever tool because you can keep buying the rubber O-rings and the spring doesn't really lose its spring, and then you can keep re-tipping it. Other solder suckers, like the ones that, like the Hako one with a plastic tip, I hate, just because you're always melting plastic and you gotta smell that. Best manual suckers out there. There's also knockoffs of this, like out the wazoo. So the quality of the one that I got, or was sent rather, the quality of this one is, you know, the upper levels. I guess you can look for the Star Trek font is the best way to identify ones that are genuine, because there are copies, cheap copies. My only wish is that it was about 1 to 2 inches longer so I could get a better grip on it. For me, it's, I don't know, the muscles have been trained. So if it were any longer, I would have trouble doing the thumb maneuver. And then that hand gets tired and you start doing this. But yeah, this muscle, by the way, if I need to crush somebody's skull, I could use this thumb to do it. This thumb has been training my entire life. This thing will be able to fucking create diamond out of carbon. It's like this muscle here. I could do the palm strike through steel. Okay, so we need to figure out what the pins are for this thing. And then I'll bring us into the actual design. All right, so it's a little crusty. I could get some goof off on that and clean it up, but we don't really need to at the moment. What we're looking at is pins that go into diodes. Why are those dropping down a layer? Oh, because it's coming from the other side. They flip them around, don't they? Wait, these diodes are totally unmarked, aren't they? You can't tell which is the anode and which is the cathode. There's no marking for anode and cathode. What the heck? Maybe it's on the other side. Maybe they just put them in upside down. I've seen that happen before. They put in resistors upside down just to obfuscate them. Good solder sucker is such a nice tool, but I love solder sucking gun. When I was fixing my Amiga keyboards, yeah, if I had to re-switch this thing again, I would use the motorized solder sucker that I have. I have used that manual solder sucker for this keyboard before to put in clean out all the switches and do all that kind of maintenance stuff. That's probably why I'm able to win any thummy war that I'm in. And in fact, it's like the nuclear option. I break their hand when I go to press down their thumb. Their thumb just squeezes off, a little water balloon. But that's because I manually solder sucked 104 keys. There's a white bar on them for the cathode. It's like slightly more prominent, yeah. I guess that is a white bar behind the... It looks like it's the end of the diode, but it is a white bar, you're right. You were correct. That's weird, though. They don't flip these. They're not going into the same... Oh, they are going into the same bin. I see. These all go to the anodes. And the cathodes are connected kind of under the board and also to this line here. So the question is, on the rows and columns that we have coming into the Sonics, well, or do the dip switches interface with the other microcontroller? That's the other question. We have one that's been removed. I can take a look under the stupid metal the giant metal tray that makes this a nicely weighted keyboard also grabs my the magnet for my multimeter. They don't appear to be connected to much at all. They do not appear to be connected to anything. So the dip switch is part of the regular rows and columns that the Sonics microcontroller is scanning. And then the next question is whether or not it's a used row and column. I mean, the columns would be universal, so that's maybe not the way. So I have an option here. I can't get to both sides of these. I could solder in on the diodes. The diodes connect to what? Okay. probably the row that they're on. So if I go back to ohms on the multimeter, bring that over here. Look at this end of the diode here. Each of these is on a different row. Nope. And none of these are not connected to each other, right? No. Usually they would share. These are probably connected to each other. No, they're not. Okay. So if I go to the butt of this, come on, man. That's got kilo ohms. There we go. Okay, so it is sharing with like regular keys, like the F10 key shares this diode, and then this side goes to the switch. So then this is going to be a column of its own, probably down here. Sorry, a row of its own. Let's just rake. No. A little click noise. All right. The Sonix microcontroller has a very logical, there it is, has a very logical layout of all of its pins. It's basically general purpose pins, and then power and ground are like pin 1 and pin 28. It just has grounds on the ends. So pin 1, 2, 3, 4, 5, 6, 7. Pin 8 goes to all of the dip switches. Pin 8 which I have not associated with anything. Pin 8. So that actually gets us to our switch. So then the modification could be to run ground into one of the diode inputs. And then we just tack onto pin 8 over here. That's a beautiful little solution there. That's a nice little thing I can do. So let's mark it. This, I can't save this document because of the permissions on the file server are all fucked up. So what I can do is I can just take pin 8 here and wire that to our batong. So the batong is actually TP6 boot. So pin 8 here. Oh God. 1, 2, 3, 4, 5, 6, 7. What? Oh, pin 8. Okay, yeah. There. Tool, hit N for name, and boot. Boot. Connect pin 4 and boot. Yes. Connect pin 4 to my freaking boot. Okay, so that, cleverly enough, that is just going to give us boot control over the microcontroller. So what I need to do is actually on the board itself is I'm going to need to get rid of the diode for whatever pin I use as ground. And then the other pin is the entire row, which is a little bit of a problem. That's a little bit of a problem because of the way the switches are. Let me clean this up. This is bothering me. I'm going to go get a Q-tip and clean this up so it doesn't look like I puked all over it. That's like Gonad's recent favorite streamer is Boom, with a lot of O's in it. I don't know how to do a shout out because it's too many O's. I don't know how you can even find the streamer. It's too many O's. I know it's the fact that I'm not fighting the file server. The permissions are just borked, and I can probably fix them with just a little bit of work. Some rebooting and retooling a little bit of that stuff, but I haven't gotten around to it, so it's my inaction, which is really the problem here. Boom's cool. Boom has a really cool like VTuber setup where it's all in Blender. It's very cool. There's a lot of neat stuff to be done there. I should probably set up a VTuber at some point. I don't know. When we do streams like this where we're doing like CAD, I could be sitting at my desk. Although this is like a little bit of reverse engineering and CAD at the same time. So, but yeah, so we know pin 8 goes to this entire row. The only problem with that is that the way the buttons are set up, I think it's crisscross. Although if one side is short, that would help us. Let's just check and see if we could get this in either orientation. It'd probably be like this, because it's probably this one and this one are connected. I think that is the case. Okay, so maybe we can get this in. It's very hard to test these pins when he's moving around like a crazy person. He just made a noise. Oh, it's the goof off container making a little suction noise. That's a very creepy noise to hear. You just get this. Your otherwise pretty quiet shop. Please just make a connection. Oh my God, do it like this. There we go. Yeah, okay, so those are connected. So if I were to put the switch in here, I'd want it to be like this. But I can stretch those pins in order to get to the 4 zones. But that would mean that one of these needs to be ground. So I could probably this part doesn't go anywhere. So if I do D10, well, that's all the way over here. Oh, that is actually, so this one here, well, I could also do this one, but that's all the way on the end. I would have to put the switch into the side, which is also fine. It could have been kind of cool to put like an LED over here, but I don't really need it. I've got the front LEDs. So desolder this, and then all I need to do is just scratch here, and I've got my ground set up. So let's actually build that. Let's make that. What I'm going to do is, I guess I can use hot air. Well, I could use hot air, or I could just use the big soldering iron. We'll just use the big eye. Hey there, bud. I heard you solder when you get kind of warm. Guess what I have? Warmth. Oops, I don't need this anymore. I should probably put this in like a diode bin. We need all the other diodes. They're in there for signal integrity, but that one can go. All right, and then if I were doing like real surface mount stuff, we could use solder braid on this and clean it up. Ow, this board sucks. It's all these switches are through hole, and they've all been clipped with something that makes a sharp end. So this is like, if somebody like tries to do a home invasion on me, I'm just gonna grab one of these fucking circuit boards, because it's like hitting them with a cheese grater. God damn, it hurts like hell. Working with this is like working on a fucking cheese grater. Sucks. All right, so here we've got our exposed pin, and all I need to do is just wang jangle this a little bit, and we'll have exposed copper. I could probably do it over here by the pin, but this is a little bit cleaner. Like building a PC in the 90s, yeah. I would imagine IT was a much more, I don't know, horrible field. It's a lot of injuries. So I'm horizontally scraping because solder mask is a fairly robust epoxy-like material that kind of shears off. And flat scraping keeps me from hurting the copper. I will scratch the copper, but you can see the powdered solder mask is starting to accumulate around where I'm scraping, because it's not that plastic. It doesn't flex. And as a result of the scraping, I'll have a nice grippy little pad here. Technically, if we want to get fancy, I could put a 0 ohm resistor across it. I may do it just for fun. We tin the pad. We don't have a lot of flux running around, so getting the solder in there is kind of spreading a little bit of flux. Oh God, IRQ timings were all the worst. back in the days when people ran sound cards. I miss those days, the sound card days. Here's an 0805 0 ohm resistor. That goof-off can is making these weird sucking noises. It's very creepy when you're sitting here and everything is nice and quiet, and then it goes, It's because it's getting cold in the shop. I have the window propped a little bit, and so the coldness is causing expansion from the light acetone material. It's so weird. You don't miss those days? Oh man, sound cards were so cool back in the day though. Like, look at all these plugs that I have that I'm never going to use. Yes, it is entirely extra that I'm using a 0 ohm resistor. I'm doing it just for fun. I'm being extra. All right, to the other side of this thing. There we go. So now we have ground on that one pin, and I can stretch these legs out a little bit on the button. I don't want to go up and down with it. So that we get to, oh, we gotta go way out for these things. I got a sound card just because there's a game port on it. Yeah, and the cool part about those game port joysticks was that it was literally just a potentiometer going into a pin. The reason they were on sound cards is because it was an analog input, and the sound card could get that reading off of the voltage reading off of the potentiometer. Pretty cool. And God, imagine, you want to connect something with a serial connection? Go ahead. You have a COM port. It's got a TX and an RX. Well, that's a little weird. The button's a little weird, but it should have been a little smoother than this. Hey, what's up, Gonad? I was mentioning you earlier about boom. If you want to give a shout out, because I don't know how many O's are in that. It's a lot of O's. There's a lot of O's. Just woke up at 7 p.m. I guess good morning. Welcome to the land of the living. It's that between contract. It's so many O's. But yeah, I was talking about, like, for this kind of work where I'm just doing computer stuff, although I'm not actually doing computer stuff at the moment. Doing like a VTuber might be a good idea. I don't know. I've got the model that Pixie made. Pixie Chemist made an oh bother VTuber model that I used in all the video thumbnails. This thing is really kind of reaching out there, isn't it? Jeez. Just nastify my fingernail while I'm at it. Yeah, I think, well, actually, you know what? I don't know how the buttons work. I don't know how the buttons on the joystick worked. But on the parallel port, the pitch and yaw and stuff were just literally a voltage input. It's so crazy that it was like that. It's so weird. I think, were the buttons a shift register? They might have been a shift register. On the Nintendo controller, they were shift register. That's why there's 5 pins, because you need a clock, you need a trigger, and then you need your data line coming back in, and then you need 2 power. Boy, that's a little sloppier than I had hoped for, but it's still a button. It might be a little bit deep for the button too, so I may need to actually put a different tactile button in, but I can figure that one out later. For now, if I solder this, presumably I will be able to look at pin 8 and watch it go to ground when I hit the button. And that'll be our boot button. Better than factory, looks great. Beep, 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 beep. Okay, let's see here. So if I go here and I go to ground to the Garfield the Narfak. What are these doing out? Go home. So if I do this one on ground, so here's a ground here, and then this one on pin 8, oh god, I can't even see it. Yeah, that's actually for the Pico Pi to go in bootloader mode, but it's also the way that you load software into the setup. There we go. Oh, you guys didn't see it. Try to get it all on camera all at once to see the kind of fancy footwork that I'm doing. Ta-da! And so that shouldn't affect anything else. The thing that they originally did is the dip switch was just its own row. And so as the software went through the columns, it would hit the rows of, it would hit it would activate the different rows and scan the columns. So it would activate the row and then scan the columns and get the position of all the dip switches. We don't have that. We just straight up program QMK to be whatever we want it to be. So instead, I'm utilizing the hole in the back of the keyboard to have a button that's hard to get to. Because remember, you can press this button and mess up your keyboard. I'd have to find where I put all the software and stuff. So I have it pretty deep in this tray. And is it interfering? Shouldn't be. Seems like it kind of is. Oh yeah, it's sort of buried in there. It's a little bit off kilter. I don't think it's interfering. No, it looks like it's in a good position. It's just a little bit off center, but it's fine. Yeah, you can accidentally delete your software in your keyboard, which is a little weird. It's a little strange. All right, so now that we've done that, we know that we can get through there with pin 8, so there's no other need for modification. We can design the rest of this PCB, and I can make it a little bit smaller because we don't have to deal with anything in this area. Basically, what we're doing is placing a bunch of pretty large stuff. I mean, this platform, where did it go? I had it. There it is. This thing is pretty big. I mean, there's a lot of pins on this thing. There it is, Narfel Garthok. That's the... So I'm kind of planning on putting it here. I could rearrange this in any which way I kind of want to. It seems like most of the pickups are just these two sets of pads. I don't really need anything else. I have an external header that will bring wires through the two holes here and bring it to the other side. So I've kind of avoided stuff there. I pushed it up in that direction. The original one had it like this. I could maybe push it this way and then have a flat, like L shape on the board. I've mapped out where this connector is, so I need to figure that out. D15 connector, the game port used had MIDI too. Yeah, we used to buy the MIDI cable. I could also put it here, although I think it would be a little bit more restricted in the enclosure. If I put it up here, the cable can push it down. Although I'll probably end up using VKB tape on the other side of this. Because I could run it like that. And then it would just be this area. Although putting it up higher means that water is not going to hit it. Yeah, I'm using the existing USB port because there's... Oops, that's not right. The USB signals go directly into the micro. Wherever the micro is. We'll never know. On the old CODE Tenkeyless, this stuff was on its own little board. But you can see the two USBs coming in here, and they just go boop, 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 straight back with a little bit of filtering into the Sonic's microcontroller. I have clients that buy the Pi chips and use them on their PCBs now. Yeah, I don't want to do all of that work. I could run this on the Flexi PCB. It's a $1 chip. Would I need an EEPROM? Would I need to buy a clock? Would I need to figure out a voltage regulator? I don't want to do that. I'm just going to run this board, which is $5. It saves me a lot of trouble. This is supposed to be a quick project, so. Yeah, the Sonic's microcontroller is not supported by QMK. There are some folks who are putting in the effort to reprogram them and make them QMK. This board died because I spilled water on it. I spilled something on it, and it stopped working entirely. So I am putting the PicoPi in because I have another keyboard that I did this with, and it's fine. It still works. So I think you'd have to pull the USB from the exposed pins on the back of the Pico. Nope, we're going to get it right here. Boop, boop. That's your D-, TP2 and TP3. TP2 and TP3, positioned correctly, will be soldered from the other side of the board. So I'm able to get to those test points. I'm able to get the reset button test point, a ground test point. I don't know why I have that one in there. And then TP3 and 2 will be our D- and D+ connections. Yeah, I think maybe we just leave it like this, and then I take a bite out of the board here to avoid that connector. Although moving this to the left a little bit would probably be good. I'll have to actually like manually do it. Because like I could move all the way over here. That's going to make routing the traces very difficult. That's going to be very annoying. But if it hugs, I mean, if it hugs this, then it's a little weird, isn't it? Because then you got to maneuver the connector in here and plug it in with this thing right in the way. Yeah, that's what these are. These are to bend down to the pins and then have little solder bridges across. The idea here is that there's no wires. No wires, none at all. And I want to keep it tight to the bottom here because if I can actually get this thing out of the way without hurting itself. Hold on. Come on. What the okay, hold on. Getting it. I'm getting it. Put that over here. Put that away. Turn this off. Okay. So down here, you know, there's stuff here. So the Flexi PCB is going to be sitting on top of this stuff. I'll remove the clock and, you know, I don't think I'll remove anything here because we'll just get 5 volts filtered on the 5-volt input pin to the Sonic's microcontroller. But this thing will be gone, and then I'll bend the board down to meet these pins and solder bridge. Now, I've done stuff like that before where you take a picture of the PCB. I could have done, like on the scanner, take a scan of the PCB. I think you can import a canvas. I haven't done it in the board layout portion. I'm not totally sure if you could do that, because I don't see the regular importing tools. Library tools, simulating tools. I've not used the simulation tools either. I don't know if those are any good. Run user language program. There might be something for, like, you could take a picture into Fusion 360, the Fusion part of Fusion 360. You can take a picture and make that your canvas, and then trace the board and output that as a whatever it is, vector drawing format, and then import it as traces in here. That maybe would be the way to go. I'm not sure. What I did is I just put it on the document layer, and I did a square by using calipers. And then my origin point is, of course, stretched all the way to here. So that way I have XY coordinates for all this stuff. So that can actually go. We can get rid of that. You get the X. All right, so I have a couple more components that need to go in. The way that I have this currently designed is that it's getting very close to this connector. That way, when you plug in the connector, it'll lean down on top of this thing and hit the reset button and make your keyboard not work anymore. Yeah, the newest Pi 500 uses an RP2040 to run QMK and control the keyboard that way. Well, we're just using the RP2040, but nice project. I like it. Thank you. This is a quick one. This is supposed to be quick anyway. I think you have to pull the USB from the exposed pins at the back of the Pico. I did that with the other one. With the other one, I actually scratched up the D plus and D minus, but here we have these test points, and I'm hoping to utilize those. But having this here, I guess, gets it up high and out of the way. It's up high, it's out of the way. The cable will be across this portion of it. And I guess that's okay. I guess we'll live with that. It's going to be a weird setup. But, I mean, honestly, like I could probably have put it down here and have these two be up top and then all of my components over here. And it would take over this part of the keyboard. And when I spilled something on my keyboard, this would be underwater. So I'm going to move it up. We're going up instead. All these decisions. And I could do it like that. If I do it vertically, well, that just makes it larger, doesn't it? It goes vertical, and then I have... What's in this portion of the board? Oh, God, this is hideous. This is the old one. Oh, well, there's a foot right here. So I might run into a little bit of trouble with that. Oh, but it's going to be over here. Yeah, where there's still a foot. Things are still afoot. Oh, but there's a lot of room. Like, this is where it's catching on this. So it's actually... Well, how far in would I have to move it? The other one didn't run into anything. Oh, but the other one's moved over to the side a little bit more. Yeah, that's just out of the way of this thing. The foot. But if I move this down a little bit, I think it'll be out of the way sufficiently. Can't really see through this, so I don't really know what kind of space there is back there. Oh, there's actually lots. There's tons of room. Hold on. Yeah, I think there's a significant amount of room. I don't think I'm going to run into anything, even if I put it where I'm putting it. Can you coat this board in solder mask so it can withstand? I don't think so. Not with a flexible PCB, unless I've got a reinforcement on the whole PCB. The stuff that you would coat it with is similar to the ultraviolet epoxy that I used on this stuff, but it'll crack off if the board flexes. So I won't really be able to do that. I'll have to go eat. Did you ever get that pin out from under the board? We poked it through and it fell out of the side. So yeah, I got it. Yeah, I won't be able to do flexi PCB necessarily. I will, however, get to do this and not have a whole lot of extra wiring. It'll be just these two chips and around to the thing, and it'll just kind of hug this area. So without any additional wires. All I had to do was technically one wire. Technically the one wire that I put on is the 0 ohm resistor that I put to ground over here. So, so that we could get this button to work. All right, so we're going to keep it the way it is. Move it over just a little bit, because in my mind, I figure the cable that plugs in will support, will hold this to the keyboard and not keep it from rattling. I'll also probably double-sided tape it. Hey, Copper, what's up? What's up, what's up? All right, so Q1 and its resistors and all these guys over here will need a home. I'll have to figure out where they go. I won't put components on the other side. This is essentially going to be like a one-layer PCB. We'll drop to the other layer with vias, I suppose. We'll need to in some places. And these two are fixed. I cannot move these in relation to one another. They are fixed. Same with this thing on the document layer. Now, how do I add, let's go to the board outline layer, and we can mess with the shape. So route out cooling edge housing, blah, 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 blah. B outline, where is that? Test mark, silk, restrict pads, patch, IDF debug, what? Reference islands! To silk? No. Crop, what does the crop layer do? V-score, map, document reference, holes and drills, test bottom. No, we'd go to the doctor for that. Board outline, there's our layer. So this line is a 0 millimeter line that exists on the board outline layer. We've got a couple of board shape tools here that we can use. Oh, they made outline circle. So did they finally fix, when we did the slip ring, we did this in Fusion 360 a while ago. This is 2020 that we did this. So in 2020, in the, what is it, 5/26/2020, the midst of the pandemic, we built this board that is a slip ring for the steering wheel, and it's got 3 circular traces. Fusion at the time had no idea how to handle that. And what it ended up doing is where the traces connected with one another, it filled in the entire inner area with copper just on its rendering thing. So this was a major pain. I had to do some little tricks with splitting up traces to make those rings. But it seems like outline circle is something that it can do now. Yeah, the case USB is going directly into the Pico. You just use the USB input directly into the Pico instead. Well, yeah, but then I would need a wire to go to it because they didn't bring it out to any of the solderable pins. I could plug in the keyboard from this connector, but I would rather utilize the USB-C connector that's built into the case. These USB lines here are not run out anywhere except for the 2 test pads. So instead, I'm just going to connect the test pads at the end of this whole nonsense here and connect USB that way. I could do wires to this plug, but I'm not doing that. Yeah, we're using what's already there. Packages are still late. That is a shame. Connect the Pico USB micro to the case. I don't need to do that. I don't know. This VSys is going to go to the 5-volt pin of the micro too. Oh, we need to put that in the schematic. What are we doing over here? Oh, VBus. What did I use? Did I use VBus or VSys? I think I used VBus. VBus. It's VBus. I used VBus. We don't use VSys. And then I used ground. Okay. And then 3v3. What are 3v3 enable? I guess did I do anything with that? Which one is that? Ground 3v3 enables directly below. Yes, so we just skipped that one. And then we went to 3v3 out, going to the rest of the circuit elements. Okay, so yeah, that's essentially what I have got going on here. We just need to connect the Sonax microcontroller to its stuff, which I did. USB VDD, VSS, data clock, VREG 33. Of course, we don't have that anymore because this chip is gone. Yeah, that looks like everything's set. I don't know why there's 2 pins going to the backlight control. What's up, wonky robot? How you doing? Oh, it's something in my hair. Wait, what is that? I'll never know. It was like a piece of circuit or something. Yeah, I think everything in here is complete. We have all the connections that we need to make in the schematic. So the schematic is done. So now we can move on to the board itself, and I can do the little swoop-de-hoop that's going to avoid this piece here, we need to find a place for the transistors. That's going to be kind of a thing. I mean, I guess I could just put them down sort of around here. So what we do now is we group sort of functionalities together, and we try to clean up the air wires. The air wires is what this cat's cradle stuff is doing. Those are essentially, this pad needs to be connected here. I don't know how you're going to do it. Good luck. Here's just a line that'll help you visualize that. So we can turn off certain ones. And I like to turn off ground and power, because the first thing that we're going to lay out is all of our signals. You lay out the signals first. So here's the methodology here. Get the schematic done. This is everything that I need my circuit to do. Get the positions of the physical items done. These are the things that absolutely have to be located in a certain position. Everything else can change. I can work with everything else. As you move through, you're going to be limiting the amount of possibilities, and your decisions will become a little bit more solidified as you move. So these components do this. They need to be in this area. Let's get this into a certain area. Let's group this in a certain place, and let's try to get those air wires to look clean. And eventually, you'll sort of start to run out of things that can be placed in certain areas, right? To aid in this, you can also go to the schematic and highlight associated parts, and then jump over to your PCB. I don't think I need to use the button there, but now it's highlighting R3 and Q3. Those are associated with one another. I don't know why it's over here, though. I don't know what the box is doing. So I know that these two are now selected, and I can get them to be in sort of a group together. So in order to hide ground and power, I need to bring out ground and power. So what I'm going to do is I'm going to place a dummy trace over here on ground and just pull it out in this direction. So here's that ground wire. It's a very thin line. Go to the properties, and I can do air wire hidden. So now all of those ground air wires are gone, because the ground is going to be a fill at the end, I think. I'm not sure. We can now rip that up, or no, unroute that trace, and I can go to 3v3. And of course, I will have to put these back in later on. But our power traces are not subject to, well, they are subject to noise, right? Like everything is in a shared system. Everything is subject to noise, and you know, you need decoupling capacitors and all that fun stuff. But within our system, within our board that we're designing, ground and power can do some acrobatics in order to get to where it needs to go. It's all these signal traces that I want to have be minimalistic and clean and all that stuff. I don't really know if I need, you know, the rules about putting capacitors down are not as clear as they potentially could be to me. You know, decoupling capacitors, fine, you barely need them, but I guess they're a thing that goes in. But for instance, I have, hold on, let me just do this. I'm just gonna knock the mic. I have two analog inputs to the Pico Pi, and the Pico Pi is going to be switching digital lines in order to expose 3 volts and muxes to various columns and rows. And scanning 2 rows at a time. I had no problem at all with noise on this board, but those wires are going all the way around to here, right? And then these wires go over to here. So I haven't run into any noise. Do I need capacitors and stuff on it? It seems like maybe no. I mean, so a keyboard is going to scan rows and columns because it does not communicate in parallel to the host. And so every computer, every USB computer is going to have some kind of what's called a microcontroller in it, which is like its own little computer. Microcontrollers are programmable task-specific chips. So what this will have is a programmable task-specific chip that can take something called QMK, which is Quick Mechanical Keyboard. Quick Mechanical Keyboard is supported by a variety of systems. We've decided on one that's $5, and I happen to have. So, sheet of foil inside the case. I don't even know if I need to do that. I mean, this one seemed fine with noise, and it's a mess. So, I just don't know. Like in a professional system, you would see some type of a filter design, but I don't really. Yeah, I didn't really need it. And the Max chips are so slow that, yeah, I don't know. These are very slow. I could replace them with digital muxes and probably do a lot better. But these happen to be on hand. I have tons of these things. I'm going to run out of these eventually if I keep using them and stuff. But they seem to work pretty well. These things also work, these muxes also work in modular synthesizers, which just tickles me pink. It's kind of crazy that these work with modular synthesizers. So our other design, our testing module that'll do its own little self-checks is going to use these muxes. Engineering condiments. Oh, I bought those chocolate sprinkles at one point. I'm like Mr. International. I tried all kinds of cool stuff. The Scandinavian chocolate sprinkles that they put on their breakfast toast. Those are pretty good. They're like not super sweet, which is hard to find in America. All right, so it is just a C1, 2, and 3 situation. So I could put this mostly anywhere. What is that connection? Oh, that's right. These are operating at 5 volts, aren't they? But everything else is pin compatible. Let's just double check that voltage. Are they working at 3 volts? Hold on. Let's double check. This is one of those easy to mess up things that'll bite you in the butt. What is that line? I think that is a 5-volt line. So this is power coming down and going to 2 pins. 5 or 3 volts. I need to check that. I need to make sure that we've got the right thing. So what is this line right here? Go to ohms on the multimeter, settle this one. Yeah, an ASIC is an application-specific integrated circuit which does a job and is not necessarily reprogrammable. Although I guess programmable ASIC is a thing in the vernacular. Okay, that is direct. That's 0.9, 0.5 ohms connecting to USB power. So yeah, I'm running these at 5 volts. And I'm not doing anything to lower the voltage into the microcontroller because the RP2040 can stand 5 volts. Paul Stoffrigan, looking directly at you for making the TNC4 not 5-volt compatible. How can you, in current number of year tag to be replaced later, make your microcontroller platform not withstand 5 volts? It's very annoying in a world where people like us are stuck using a variety of technologies from around the 5 to 3 volt era. Things are like 1 point something volts nowadays and everything's an ASIC. I thought it was only 3v3. It runs off of 3v3, but these parts I don't think run at 3 volts. So I'm running them at 5. It's able, the logic voltage is above threshold, so it's able to control them just fine. These are just getting 5 volts. Let's just make sure that that's in here. Oops. Yeah, I have them running at 5 volts. And so the keyboard itself, the rows and columns are being energized with 3 volts. Oh, that's how I got around it. Right. So these are capable of maybe breaking the RP2040. Let's double check that. They're capable of doing it, but they don't. RP2040 data chart. A microcontroller by Raspberry Pi. It's like you're sitting down with a novel, because this thing is a 646-page document. So it is basically a novel. Dear God in heaven, look at all these fucking pages. What does it all mean? Oh my God, I just want like a dinky little data sheet. Holy shit. I'm looking at the RP2040 data sheet. Yeah, I don't think we need a Pico 2. I don't need that. I don't need that business. Geez, I don't even know where you'd start. Like, what's the minimum design of an RP2040 circuit? I would need a voltage regulator and a couple other things, right? General purpose digital input and output. RP2040 can connect to a number of internal peripherals. They don't give me, where's the maximums? $1,100 pages? Ay, ay, ay. Yeah, if I search for absolute maximum, I assume that it's going to be in the initial tables, though, because that's usually where they put that information. But then you get to microcontroller data sheets, and all bets are off. Yeah, we're already looking at code. Maximum. To the maximum extent permitted by law. No. There it is. 523.1. These guys just can't decide on which header is supposed to be the important one. 523 pin specifications. 5231 absolute maximum ratings. Jeez. Voltage at I/O. I/O VDD plus 0.5. So I/O VDD, I mean 3 volts is the maximum. So what I'm doing is I'm basically giving these analog switching chips the authority to blow up my microcontroller. But they will not blow up my microcontroller. I trust them. Your life is in my hands. And they're sitting there shaking with the knife up to my neck going, I can't do it. No, I won't. I won't hurt you. Because we're essentially giving them 3 volts in the common port here. And so the analog inputs are going to see 3 volts, not 5. There's potential that it could maybe spike, but this keyboard's been fine for a couple of years. So I can't pull the trigger. I just can't do it. So yeah, that's essentially what's going on here. And I actually changed the order of these in order to facilitate my wiring, which is why I'm kind of putting them in the same position, because I figure that might clean up some of my trace routing. So it's not 5-volt compatible. It's being held at the edge. It could be just one wayward twitch and the whole thing goes up in smoke. I live on the edge. Okay, so that is in fact our full schematic. We've got everything we need here. Let's do the board shape finally. We had to double check a couple things in order to do the routing and wiring that we wanted to. But yeah, C1, C2, C3. And then we've got the 3 transistors, and I want to avoid, let's just get them off of let's get them out of the way first. 3 transistors that are just simply, well, why are we bit flipping that? Oh, you know what it is? We're bit flipping it because the RP2040 cannot sync the amount of current that I need it to sync. Even though it is just like activating other transistors down the line, for some reason, I need a little bit more current than the RP2040 is able to provide. Puff magic smoke. We don't like to breathe that here. We don't like breathing the magic smoke all the time. My hair has started to hurt. I think I need to schedule a haircut soon. But I'm going to be streaming Friday. We're going to be working on this thing again because the more work we get done on it, the closer I get to just ordering this and moving on to the other projects that we have to do. We're doing kind of like a whisper down the lane, and I pulled this one out of nowhere because we needed a little bit of variety. I need some change, you know. I need to kind of keep myself fresh. And so what I did is I pulled out the keyboard project as something that needed to be done, and it's a relatively straightforward and easy thing to engineer. Would it make sense to use 3v3 Zeners as an overvoltage protection just in case? Look, I had this thing for like 2 years. It's been working just fine. The RP2040 is a $5 chip. If it blows up, I can do a redesign and order some more $2 boards. But as it is, this is pretty rock solid. I've had no troubles with this keyboard at all. I mean, technically, the way that I would really do it is redesign this with a 3-volt mux. The Max 308s that I'm using, it's something that I happen to have, right? I just have them. That's why I'm using them. I would use a different mux, faster mux, a digital mux, and then it would only get 3 volts and everybody would be happy. There are diodes from the RP2040 input pins to the 3v3 rail, which will hold the input voltage at just above 3v3. Oh, that's nice. How quickly does it blow up in that case? With the diodes screaming at you. Laying out the components and traces is the most fun on my last project. What kills me about doing this is the infinite possibilities and boiling it down to very few. It's like, you know, is this the best choice? Putting this all the way up here? Am I really making a good choice doing that? I don't know. I don't know. It's sort of, it bugs me in a weird way until I can finally narrow it down. Like for me, the most fun part is the mechanical task of laying things out in an organized way. When I start to wither the possibilities down to a very narrow set of decisions. It's this stage where my head is in the clouds and I'm wondering which one of these stupid decisions I'm going to make now is going to come and bite me later. Because that happens too, where you're like, well, I didn't need to do it this way. Why did I do it this way? And I guess we're going to just try this. I'm going to take the bite out of the side of the board here and then smooth out everything. And maybe that'll get us... Actually, it might be better if I move this just a touch over. Nah, we'll leave it the way it is. Board shape. Outline polyline? So what does that do? Creating a new board outline, but it's got like dimensions to it. So I guess what I can do is take the bite out of it, and then I can use the miter tool to smooth it. I could do a spline line, and that would be very weird. That might be a little too funky for us. That might be a little bit too funky. I guess another way to do this would be to ignore the board outline until you've made the design, and then you can figure out the board outline later. Okay, hitting escape apparently did that. Sweet. Like, I just do this, and then we design the circuit, and then we come back in with the board outline. Rule number 8, all decisions come back to bite you, especially the decision to make that rule number 8. What is that for? What's this one? That's not origin. What are you? You're some kind of a label that's no longer there. Of course, doing it like this, I can't see around my my holes here, the routed holes. So I'll do a rudimentary initial board shape, and I'll do a polyline. Start over here, and we'll do a right angle on that. I'll go approximately to here, and we'll avoid our connector. Give that just a little bit of breathing room. Come up pretty tight to the back side of this thing. And I'll bring that home over there. So now we have a complicated board shape. I probably should have put that in as 0. Here, I can make the line width 0. So in order to do that, we have a tool that's called the change tool, which is absolutely nowhere to be found. Where's the change tool? I hit the letter C. There it is, C for change tool. And I can change the size, ... to 0 space mm. Invalid, oh, it thinks it's text size. So C for change again. Nope, I have to escape to get out of the change tool. Hit C for change. And then we need to find a width. There's width. And 0 space mm. There we go. So now we can just click on these using the change tool. Change tool is an old school way to do it, but it is pretty useful to be able to just like point and click all the stuff. What the heck are you? Little line segment hanging out. Now, because it's the 21st century, we're actually going to roundinate these outlines. So I think I can use... There is no miter tool, is there? Meander, routing, board shape, place. That's not... We're not interested in placing. The miter tool exists in... I guess the other sets of tools, huh? Line, arc, blah, 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 dimension. Mark's local origin. Oh, no, mark. It's mark local origin, not marks. Mark has nothing to do with this. Simulation. Yeah, it's like all the other, like the PCB symbol and the schematic and stuff like that. They had a miter tool that would allow me to soften the edges with a chamfer, which is what I wanted to do here. But it turns out I don't think I have that. Yeah, I do want to keep the total size under 100 by 100, and it is. I kind of looked at that when it was still a square board. This is well under 100 by 100. I don't know if I need to move this back to origin or not. I don't know. I guess we could make that a little bit more even. That's going to crunch the room I have to run traces, but it'll open up the area for the plug to go in. So there are diodes. Oh yeah, we already read that. Okay. I mean, you know, the debate is whether or not I use just the RP2040 chip, which would make this so much smaller. I could probably try to squeeze it in like right here, and or just barely have this up top with the RP2040 chip just laid bare. But I'm resisting that urge because I've got the Pico Pies sitting around. But with an RP2040, like, I mean, what? I guess I can't see it on that board. This is the Seed Studio Zhao board. I wanted to see what support equipment they had on this one. Oh yeah, no, there's not enough ins on the Zhao for me to use it in this. I could have made it a wireless keyboard. Oh my god. But it's you know, if I did like an I2C logic thing, or if I got a mux that just spoke I2C, I could probably use that instead, and it would lower the number of pins. Because really all this thing is doing is activating a row and a column and then reading the 3 volts. So all I need is 2 analog inputs into this thing, and the rest is just controlling stuff. But it seems like it's a little easier for me to just run. Getting the can off of something like this is very difficult to do. It can be done. ChipQuick is actually really good at that. But then I could peek in at the design and see what it looks like. Actually, we could just look it up. Just see what Seed Studio put on the board. How do you spell Zhao? Seeduino. XIAO. Do they have they probably have a canless. It's the RP2040. Ooh, they did a fancy thing. Okay, so somewhere around here, they might have a canless PCB layout. Taken from their engineering files. Actually, I do have the Zhao 3D model as well. Maybe that would be able to. Oh, you found it? Yeah, I'm not gonna change up the software to use like a digital mux. Let's just get this PDF. Oh, this is the schematic. Yeah, I was looking for just to look at the board layout. That's okay. Yeah, voltage regulator. That's what our USB-C. They've got their crystal. And then whatever this thing is. I'm gonna cough, hold on. Oh, damn it, come on, man. My Stream Deck freezes in the middle of stream. I'm gonna wait to cough. I don't want you guys to hear me coughing. What I'm okay, so what I was looking for there. What the hell's wrong with this thing? Whoa, okay, there it goes. Okay, what I was looking for there is like the bare minimum RP2040 layout, like what it would take. I'm not looking to use the Zhao in this keyboard. I know that I could make it work, but I'm not going to bother because there's a lot of I/O that I kind of need. And doing the basic RP2040, just soldering the chip down onto this board, that's well and good, but it's not good for my first foray into flexible PCB design, right? It's sort of, this is my first time, so I really don't want to go crazy. So this is kind of an issue. I don't have the same sorts of tools that I would have. Like I can do an outline arc, I can do an outline spline, I can do a polyline. That's all well and good. I was hoping that, oh, here it is, rework. Okay, there's the miter tool. Okay, it's me. I'm the dumb one. So let's go out to like 5mm and see what that does. That looks nice and soft. Bonk. Yeah, why not? This is just going to get double-sided taped from the other side, so. And so all I'm going to do is just sort of soften up the edges. And if I want, I mean, I guess later on I can come back and redo the outline a little bit more, but the RP2040 stamp. The real way that I should be going along with this is if I really wanted to make this not a personal low bother project and I wanted to make it something that like people could buy, is I would go directly for the RP2040 or another microcontroller that doesn't require me to, you know, well, actually, no, this one's $1. $1 a chip is a really nice little price. It's a nice, tidy little price, as opposed to like, you know, out of production $14 microcontrollers. Doing like an Arduino would be nice and easy on the thing too, which I've done before, but you know, whatever. Okay, I'm up to date with both of my chats. No, we're just gonna roll with it like this. This is pretty good. Look at this cute little board. This is well under 100 by 100 millimeters. If I were to box this thing and just go to the trace, go to the top layer and just do, oh, like this. No loop, top layer. Why is the trace not going down? Oh, width. Have we not? Oh, are we still on? Oh God, what's going on? Are we still in board outline? No, we should be on the top layer. What's going on here? Oh, it's only going to let me put down a trace. Right, if I'm routing, it's only going to let me route a trace. I can't click down here in order to do that. I need to do just a regular old, I mean, I guess I could draw a square document, draw rectangle. So if I were to take this design and box it out, oh, it's not going to let me do that. I'm just trying to measure it. Hey, what's up, Brink? How you doing? Whatever. This is well under 100 by 100 millimeters. 100 millimeter from the edge of the board is beyond. Yeah, there's 100 millimeters right there, and that gets us well beyond this connector. And we've actually moved this up from origin. So, oh, I lost one of my chamfers. Oh my God, humanity. Okay, let's go to design, rework, miter with a nice 5mm round. There it is, looking soft. Okay. Yeah, Happy New Year to you too. So we got a lot of connections that need to come in kind of local to this chip. Got a lot of these little guys. That's going to be a big set of traces that need to kind of slink their way around. And then, of course, some of these need to connect internally. So let's do some of the internal connections first. Now, the design rules that I have in here are from JLC PCB. I'm not sure if they are for the flexible PCB service. So we have to make sure that our traces going down have the right rules dictating them. JLC PCB design rules FPC. "5mm panel borders on all sides. Copper should present through the borders except 1mm clearance around fiducials and 0.5 millimeter around tooling holes. SMD, I don't even know what that is. Should be 1mm diameter and tooling holes too. Okay, well, first day back at work. Mad at past me for not finishing a project. Oh God, past you was under a lot of stress. They wanted me to tell you. I have no experience with the Zhao. It's been around. Fiducials are the round jobbies lining up the layers with each other. Oh, do I need to do those? Tab should be 0.7 by 1. Overall panel size 234. What? Yeah, we're using a Pico Pi, not the Zhao. The Zhao is a Seed Studio product, and it's pretty cool if you want to throw something in that's got wireless capabilities, because this thing has an RP2040, but it's also got the ability to be like an Internet of Things thing. We used the RP2040. Actually, wait, does it? Some of them do. This one does not. We used it in our modular synthesizer VCO. That still doesn't quite work correctly. I need to make a much larger range from the knobs, and it's all software stuff. We'll get back to this one at some point. I also have big regrets with this board. We should have gotten this board in yellow, and then the pinout difference with the little modification down here. I need to get that into CAD, and I need to get the button correction into CAD too, because I wired the button wrong. I made that part wrong. Also used in pick-and-place machines to mark origin points. I see. They look like a big unlinked test point. You're bound to have seen them. I have. I know exactly what you're talking about now. Yeah, they're also used in screen printing, so you can line up all of your different colors. But it's something that both a machine and a human can use to align different things. They're basically your datum point. So I don't really know about these specific. All right, well, let's just go with the DRU that we got from the rest of the program here. I see column 6 is wired to itself, and of course we're going to be doing rounded traces. That's just a given. So I've got a regular spacing and I've got an alt spacing. The design rules are going to hopefully keep me from running into stuff that I'm not supposed to, like when traces are a little bit too close to one another, or if I'm too close to the edge of the board. Presumably my DRU is going to keep me away from that, although it does appear that it's let me get pretty close to the edge of the board. I don't know if that's 0.5 or not from here to here. They don't give you a lot of measuring tools with this. So that one is also connected where? It's connected to CC8. Yeah, so somehow that's going to have to connect to itself. So that'll change the shape of this trace, and it means that some other stuff is going to have to kind of go around it. Or I could drop that down to the bottom of the board. The grid spacing is something that I wrestle with constantly. It's something that's that I have trouble with, and I don't know what a good grid spacing is. That's what I've learned over the years, is I don't know what a good grid spacing is. So unroute that, and that's going to go to a via. So what I'll do is I'll keep this tight hugging thing right there, because everybody loves a good hugger. And we're going to take this one straight out of the flexible area, and I'm going to drop it down here. That might be a little big for the via. I guess that's just where we're at with this. So take it out to here, get rid of the end of this. Oops. Nope. Because then, actually, we're switching layers there because we need to have a trace come out of this. I guess this will come out, and then I'll put a via just at the end of it. I need to use the alt spacing so that these line up. You're the, what? What? Oh, C6 is not, hold on a second. Got the wrong one. So these are lined up, and then this one connects to the other one. So actually these, they still need to leave this area, so this can go, I guess, just directly to itself. That's going to be a tough one. Yeah, because it's going to be all stupid. You're dumb looking because of the spacing. There. That's a weird one. Actually, no, because it's going to need to... Well, if it leaves on this layer, then I guess I can deal with it like that. Yeah. and I'll just make a little weird curvy doodle. But then C6 needs to cross it. So we'll take C6 and we'll come out here and drop down a layer. And then we take C6 over to, I guess we've got to be kind of surface level. It's not very elegant. Yuck. I mean, I could make that just a giant curve. And it doesn't really fit. It's kind of awkward. And I don't want the via to be close to the edge. You got to kind of watch out for that kind of stuff. So I guess we're kind of stuck with it like that. At least C7 can exit on the surface. These other lines are going to have a little bit of trouble routing, though. And I'm using rather big traces on it. I'm just going to keep it as big as possible for a little while. Oh my God, this thing is a nightmare. That looks a little weird, but I'm going to keep it because it's just, we're using rounded traces. I don't know. It doesn't have to be pretty. Take that up a little bit. No, why did you do that? Oh yeah, the design rules are really messing with my ability to run the traces. So that's got to go up to here. We got a lot of distance to cover with this. And then what else do we have? We got 2 traces there. Those are going to go all around the place in order to get to where they need to go. These connect up to here. So we're locking in the location of our ICs. Things are going to get a little bit janky. But hopefully, we'll have good authority to run these to the right places. Like here's C4 and C5. C4 is going where? C4 there, C5 there. 6, 7, 8. Where's C8? Oh, C8 over here or something? Yeah, because they're all weirdly arranged. I see. Okay. Well, let's try to get to C4, I guess. Take a nice, well, okay, so the one that's going to make the tightest bend is going to be this one, but then I don't know what kind of distance restrictions I have. Oh boy, this is going to be an evolving thing, isn't it? It's going to be crazy. This one needs to be tighter. You know, I'm going to need to. I'm going to need to set up specific rules. I haven't looked up what JLC wants from flex boards. There are some specific restrictions. So this is C5. How is that going to work? Hold on. Over to here. That. And then, yeah, there it wants to switch location. So I am going to have to do row and column swaps on this. Oh, what happened here? Why does this do this to me? Yeah, see how it's just a little bit off, so it doesn't like to line up properly. So I'll put it here, but then I'm going to reroute this one so we don't have that little line segment in there. And instead, our line segment will be under the via. We just hide it under there, the little, you know, off-kilter stuff. Okay, so our connections are C76543. 776543 needs to go to 321. I mean, I guess maybe I can flip them. If we route them the other way around, then maybe I can do all the weird via stuff that I need to do in order to get them in the right order, and then I don't have to mess with my software. But the thing is, like, I can swap rows and columns just as easily. It's just I'd have to do a bunch of logic in order to figure out, you know, what's actually connected where. But that would simplify my routing quite a bit. 76543. Let's just pull this whole mess over to where the chips are. Oh yeah, look at that's the board edge requirement, huh? Wow, that is a length from the board, which means this is probably not really going to be too happy with. That is a huge distance to the edge of the board, though. I thought I would at least be able to come out down here a little further. Well, I guess we should just get it as close as it can and give that a little bit of room for routing under there. And this one needs to be a wide radius of turn, so. Might be best for me to do this another way. All right, so 7, 6, we're going to bring out here. Just getting it to look right. That's the main thing. Does that get closer? That might be. It doesn't, the milled areas, it doesn't treat the same, I'm seeing. And since we're using curved traces, the traces handling is a little bit weirder. It would be nice to get this consistent, though. But within my grid spacing is really what I'm trying to work with here. It looks like it gets a little pinchy there. I like using curved traces. They look good. Because, you know, the operation of a circuit board is all about the visuals. As long as it looks right, you know? That's what they always taught me in school. Ooh, this needs to avoid that via, which is tough to do. But I guess what I can do is take two ends. I can move this in just a little bit, and then we'll make a junction, which I kind of wanted to use the via as the junction, but it needs to get out of the way over here, so it's a bit of a problem. Oops, I was hitting Windows, not Alt. Why did... Okay, you little bastard. No! There we go. My hand shifted. It shifted from Alt to Windows. PCB should be a work of art. That's right. A work of art. That's a little weird, but it gets us out of the way of this one. This is what I'm talking about with the decisions and how many decision becomes few. Once you actually start getting the design down on paper, you start to see the areas that things can improve or get modified and all that stuff. Yeah, this is awkward. Too awkward. That's a little better, maybe. See how they get kind of different distances? It's weird. I could use more tools for fixing that in this program. And maybe there are, and I just don't know them. Hello? Tools? Go, go. There we go. Okay, so let's reroute that one. Make it not awkward. Go. Take it to where all its buddies are. So I'm routing it this way because I may then reorder the columns and rows so that it makes a little bit more sense. I'll fix that visually in a minute. Don't forget to add a spot for swapping RX and TX when they're invariably backwards. This is going around just before everybody moved to Blue Sky, but there's a way that you can order TX, RX, jumper, pads, SMD. There's a way that you can route a TX and RX 0 ohm jumper so that you can change the orientation of the 0 ohm resistors to swap your TX and RX. I don't have any TX and RX on this board. I have D plus and D minus, but I don't think I got those wrong. I think I've got those correct because it's D plus, D minus into the chip is marked D plus and D minus. So I've been looking for an analog EE streamer for a while. Good to meet you. Hey, good to see you, Beef Dad. It's a nice little debugging statement as your name there. We do we jump around. We're doing a digital-ish kind of design right now. We've been doing modular synthesizers for a little while, and hopefully sometime in the near future, I'm going to get back to the Burnout project, which is called Burn the Subs, and that's a laser etching table that burns the names of people who subscribe to the channel onto itself. Got to work on that a little bit. I've got some Node-RED that I need to do in order to take in stuff from Twitch's API in one location. Our fart box is broken. Our channel point, anything is broken. We are repairing it in order to give us so much more capability in the shop. And doing that with Node-RED means that I have a singular input point that I keep up to date. So that's stuff that we're going to work on in the future. I pulled this keyboard project out of my ass, basically in order to have something that we could clock a win on. So I'm designing a PCB that's going to do all of the wiring that I did to this keyboard as a flexi PCB. The citizens are demanding fart box AdSense. Well, let them eat farts. I will get it working. It's essential. Boogie, boogie, boogie. But yeah, the fart box is something where people could spend their channel points and they would elicit a fart from a machine, a physical fart that would actually make a rude noise in my shot. That is not right. That does not look right. If you get all the radiuses right, it looks really cool. And if you get one wrong, it's like nails on a chalkboard. That's why 45-degree angles are much nicer. Oh, it won't go to a larger radius than that. Oh. Well, we'll have to pull down the radius for everybody else then. Let me edit you. Ugh. Fine. This is going to make these so much more annoying if I need to move them. I wonder if there's a simplify trace command. There we go. Clean that up a little bit. Let them eat farts, new favorite phrase. They want farts, they can eat my farts. I mean, wait a minute. That sounds like something that no, that's not supposed to, that's not good. You know what? I think this was designed to be flipped around. No, that's still bad. I mean, those are in line. Where do I have pin 1 on these? I have pin 1 on the other direction for these. How did that end up working out? Oh, wait a minute. We might have a pin 1 in the wrong spot scenario. All that work was for naught. Hold on. Where are pin 1? Okay, we've got a pin 1 scenario. All that work we just did is invalid. All of it is dead. All of it's dead. Which is fine. This is a good thing to discover early on. Yep. One of those days. Hey, it's how it works. How this stuff is due. Okay, so we need to twist this without altering its position. The position is sacred. The position is what I measured as being the center of this component, 59.16, 43.28. What we need to do, we need to move it 90 degrees. Oh my God. it's nope, you don't get to do that. We're gonna undo that. No. This is where Control Z is very nice. Oh my God, dog, shut up. Dog is going crazy. So why did that not spin 90 degrees at its origin point? Let me get these numbers written down. Start up a Notepad++. I want to get those numbers written down. Did Notepad++ just fall behind? I think it just crashed. There it is. Okay, so 59.16 and 43.28 are my coordinates. They're measured from the actual 0 point on the board. And then I set this 90. There we go. Okay, good. U5 out of the way for right now. Okay, so this apparently is the way that all these things are supposed to line up. Because if that travels out and around, apparently it gets it to the right orientation. It actually does help that I do have these. Well, that needs to be moved up a little bit. These are like physically wired. And with the wires flat like this, that helps me organize all the traces so I don't need a ton of vias in order to route everything. They're kind of ugly on this end. They look a lot better over here. Rows are in red and columns are in blue. I don't know where that white wire is going. Oh, that's the lighting control wire. Yeah, what did I miss any Twitch like Streamlabs stuff? No, it's just silly Russell doing those gifts. It's very nice. All right. So back to this. Oh boy. There's going to be a lot that I need to kind of get through on this. So there's going to be quite a bit that's going to be done, you know, elsewise. So number 1, C4, big radius. Take that out and around. I don't know if that's too close to the edge of the board. They want 5 millimeters to the edge of the board. It's kind of a tough. Well, I'll have to see in what scenarios, because like, is that okay? Might not be. But if that's not okay, then why is this okay? And I did actually make sure that those distances were correct. I need to come way out over here because I don't want to get in the way of these signals coming out. Should be a big radius. And then all the way out over here. Oh, can't actually. That's all I can do there. We only need those 2 from over here, so we can do this. And this one has to kind of hug that one. Why is this such a big distance? Oh, because of the alt spacing. Very annoying. Yeah, not having my coordinates set up is very, very annoying. but I never know what to set them to, so I'm just kind of leaving it default. Oh, those aren't as close as they can be, are they? Dun dun dun. Boink. En route, en route, en route. Why did it change the... It's like, hey, you're having a lot of trouble with these curved traces. Do you want to maybe drop into normal traces just for a bit? Maybe we could do 45-degree angles. You won't be so stressed. No, I must curve the traces. I must. It is my destiny. Where does this one go? Why does that go there? That's a dumb trace. I mean, I guess I could do that. But shouldn't these be like meeting up with each other? I'm going to stop this one here. Yeah, how's that supposed to go there? I think maybe that's the lighting control one. You can download a DRU file for JLC PCB capabilities for their flexi PCB. Dear God, we have a lot of tabs open. JLC PCB DRU flex. Flex PCB, special offer, Control F, DRU. Where is the file? I already downloaded a DRU for general JLC PCB, but I don't know if they changed their specifications. Yeah, here's the Flex PCB specifications, which I could go through one at a time and put into the CAD program. I'd rather download a file to help me do that. PCB fab fact, get an instant quote. Stiffeners. Text size. 0.5 millimeter minimum solder bridge width. I mean, I am dictated by the, hopefully the pads on these things are big enough that I don't run into the design rule. Because I need to solder to these pads. Sold there. What are those two connected there? Do I have that in my thing? I think I do. Yeah, I think I do. Wait a minute. What's the... Oh, hold on. Dr. Plugger, hey, thank you for subbing. Very nice of you. C5. Why is C5? Oh, no, this is C5. Okay, yeah, so that's correct. But C3 just kind of comes into the middle of that and goes over to here for some reason. So yeah, C5 would be the next one to go through, but like, I would be tracing it across this. That one's C5. C5 would be on the outside. Wait, but that comes in backwards too. What the heck? How is it that I have, hold on a minute. I have one pin out here, and the other one's all meshed up. And these are laid flat, so they should be going to the proper locations, just like this does. It goes up and around, and it ends up here. But regardless of that, it should. Maybe I've got it wrong in my notes, because the keyboard was a little bit messed up. A little bit messed up when I first put it together, and I had to do some stuff in software to swap the rows. Maybe I'm going to have to do that again. And just swap the rows out here. So going on that, and the fact that we are in the right orientation, we're in the right position. 5916, 4328, yeah, that's right. Then I guess what I'm going to have to do is just run all the traces over to this area, and then I can swap columns. It's like matrix algebra. We get to swap rows and columns. I still have to see if my distances are okay too. Like if I'm too close to the edge of the board here, I'll have to investigate that. But this is going to require another trace to be added to this stack up. So I guess I need to start on the opposite end. Man alive, this is crazy. These are all the columns, 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 and then here we have rows. Rows, rows. So rows, rows, rows. Where are rows coming in? Rows are coming in this upper corner here. So those will route over to there. Okay, so move parts closer to the center, away from the edge. I can't move the parts. These two are fixed. These parts, I mean, they need a lot of room in front of them here because that's where all of this is the main bulk load of traces that I'm going to have to run on this thing, because the rest is digital hookups and stuff. So the big bulk of traces are going to go down and around. And I could make the board physically larger to accommodate it, but the position of these two ICs is completely fixed. There's no moving it. Ah! I mean, I've seen people do a lot of like big operations. I do individual traces. I do this one at a time, which is a bit tedious, but it means that I've got control of it, I guess. You can auto route all kinds of interesting stuff too. Like quick route. Boom, there it is. I quick routed it, and it's disgusting. That is hideous. That is disgusting. It might help you get some of the creative juices running though. Yeah, it's a thing. What is this one? That's C7, which connects to multiple places. So C7, 6, 5, 4. Okay, so we're gonna go down the row from C7 here. I'm gonna try to get this to follow just like a logical, go to like there. I don't know if this is as dense as it can be. I may be able to go denser with this. I have to. This one should be a small radius to there. And let's just follow that around and see if we can get that. What the hell? What the heck, man? You're not helping me at all. C6. Whoa, 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 whoa. No, we do not want to move that. Oh, alt spacing. Yeah, that's not as close as it can be. I guess I'm spacing it based on the pin spacing, and it really should fall into sort of a tighter spacing. You can be within 0.3 copper to the board edge. Okay, so that's what this space is here. That's 0.3. It's fun to do some work. This needs to be further down. All right, this is keeping me 0.5 from the board edge. I'm going to have to go into my rules, the rule set, and make sure that I've got it correct. And then these are spaced based on the pins. I should probably pull them into a tighter spacing initially. Although that's going to be some weird trace routing if I do it there. So I'll try to do it here. See, that's going to look weird. It's going to fan out. But I guess we'll deal with it. Make it a work of art instead of art, which is what I generally make. I'm usually farting. What is that outside one? Okay, so they're all going to approximately the same position. Would you stop Xing me? Oh, it's because I'm in the routing tool, not like a moving tool. Yeah, there we go. Only there were automated tools that did this. I mean, there probably are. I just don't know them. And then one more. New. Entering and exiting the tools is something that you got to kind of pay attention to with these, with Fusion. All right, that's our minimum bend. That's a pretty minimum bend. Ah, it's 4:30. So it's just kind of careful work, kind of keep it looking good and hit that alt. What's going on there? Oh, it went beyond the maximum. It went beyond what it could handle, beyond his limitations. Oh dear God. Okay. My two grid spacings do not agree with one another, so I basically have to do everything with Alt held down. Let's see if that'll clean it up a little bit. I might actually run out of bend radius. Why are you here? What are you doing here? No, 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 no. Ah, I got rid of the wrong one. It's fine. What is a DRU file? I would very much like to find one for the flexi PCB because I don't have the right DRU in here. And I'm just kind of getting through some of the design. I mean, if I build it like this, it's safe. You know, it should be totally fine. That one's going to be too big. This one's going to end up too small. Actually, that's the same radius, yeah. Yeah, the DRU files is just the design rules, and it's a fairly simple format, as formats should be. Come on. What? Oh, I hit Alt Escape. The boss key. See, here it's not letting me... Ugh, Alt Escape again. I have my finger over the escape key, so when I try to hit Alt for the alt spacing. Does it open with some sort of CAD program? It's a file that I can load into Fusion that has all of the parameters of the design in it. So why isn't it letting me hook up to C4? Here, I hit Alt, I click on this, and then it just has a conniption fit. Oh, that's really annoying. What happens if I route multiple? Oh, it hated that. That. There we go. Okay, so what I'm just having a little trouble getting the router to agree with what I'm doing. Maybe I can just get rid of this and then start from here. It really, really hates this trace. 0.2 with a corner radius. Let's get alt spacing right there. There you go. Now you're helping. Oh my God. It's running into its own design rules so much that it thinks it can't run this trace. Weird. Seems like that's probably an error. Yikes. Yeah, it's having a little trouble using the curved traces. It loads in Fusion, but you can also just edit it. Oh, cool, we're doing this. Cool. it so hates what I'm trying to do here. Can you not see what I'm trying to do? I want to build a utopia. All right, so from there, we can come out this way. There we go. Come on, you can do it. surrounded by design rules. Can't seem to get itself together. That, I think, is breaking down a little bit. I think there's some errors there. Yeah, this is weird looking. And then there's a couple more that I need to run in from there. There's 2 there, and then the bulk. There's a big bulk of them up here. We're already running out of room. I mean, getting these to fit in between the 2 of these is proving to be kind of difficult. We do have a whole nother layer, though. We have a whole nother layer if we're willing to drop a lot of these to the other layer and have a lot of vias. It's not really, it doesn't have to be a 1-layer design. And in many cases, it can't be a 1-layer design. And I need to get C6 out of here somehow. All right, I got a lot of decisions to make, but I mean, we made a lot of good progress today. We've got kind of a layout started. I'm probably gonna have to redo all the traces just because it's just such chaos in that area. But we're making good progress. We're gonna work on this tomorrow. I'll see about whether or not I can stomach actually working on it tonight. Maybe get a little bit done in that regard. And for tomorrow, we'll bring the printer in here. And I can print out this board edge and we can take a look at it. But we'll have to go in and figure out what our design rules are going to be for the flexible PCBs, because there's some different rules that will make some of our routing a little bit easier, like getting a little bit further out here. And then when we do these traces, we're not supposed to have them stacked on top of one another in the 2 layers of the board. So what the way you're actually supposed to do is stagger them. So we'll have to figure out something with that too. It's going to be a nightmare, but we'll figure it out. It's our nightmare to have. All right, so I'm going to save this. We'll probably have to redo a little bit of it, but our mechanicals are in. We'll test out, whether or not that's good tomorrow. And yeah, so the next stream is tomorrow, and I have not set up any of the commands, so I need to actually do that. We're kind of abruptly cutting it off right here. It's just because this is going to get a little tedious. Okay, so I need to go to my section for making the command, which is all the way down here. Highlight this one and cut and paste. And then this whole shit changes because it's Jan, Jan 03, 2025. Every single number is wrong in the date. There we go. So now that I've done that, I can come over here and I can do the end command and I'll have the link to all of my stuff. Look at it, it's beautiful. It doesn't look right on the screen. This one. Oh, but it's gone. It's not in there. Well, if you're in chat, you can see. Do you see the 3D just for fun? Yeah, let's do that just for fun. So the thing about Fusion 360 is that it also has a robust system for creating a 3-dimensional board. So all I do is click this button, and now it'll push all these details to a 3-dimensional file that we can even use to help, tune and tweak our layout. I have it set for the regular board thickness right now. It kind of reset its own settings. So the cutouts, the miter layers are going to be really weird. The milling layer, sorry. It's going to look really weird. Thanks, Ben Gizmo. I appreciate it very much. Yeah, so the parts are floating in space, but we've got our cutouts for the flexi PCB. The whole reason that I'm using flexi PCB is that I can interface with the pins of these 2 chips and do a total takeover with muxes. To be fair, I could probably find different muxes that would work a lot better, but eh. And then our board is here, and then we've got the vias that are going to be the solder through to the test points. I know, it's always nice to look at it in 3D. One of the weird parts about the 3D is when you render the 3D part, you're here in CAD, so you're like looking very close. You're like, okay, the distance between those 2. Looks good. And then you actually get the physical board made, and it's a lot smaller than you think. It's like tiny. You're like, I gotta solder that? Oh no. These seem abnormally large, and they're just SOIC. But like, that's still very small. But yeah, this is gonna be our little takeover PCB. How many diodes will be on this thing? The diodes are actually on the main keyboard circuit, so I don't need to add anything. This already has diodes, so we're not really going to have any. Our stuff is just wiring up to the muxes, basically. And apparently the RP2040 has internal diodes for protection. So we don't need diodes. Capacitors, I don't know. I don't really know how many capacitors. Are those cutouts supposed to be there? Yeah, so what's going on is instead of what you see here, which is wire wrapping wires that have been soldered down onto pads. So those pads typically go to an IC in a setup that looks remarkably like this. Very close to that. It looks very similar to that. But what I've done is I've taken it over by soldering wire wrap wires down. You can see that's a little bit sloppy. Things don't quite work out very neatly, but they run over here to these MUX ICs. And so instead of having all of these wires all over the place, what I've done is I've taken the footprints of these and I've turned them into flexible areas on the PCB. I don't have the thickness settings in here for flexi PCB, but these will be very thin indeed, and they will be able to flex down onto those pads where I can do a solder short to the pins and then have the pin functionality all worked out. That's the plan anyway. So yeah, I need to do some soul searching here. I need to actually go and take a look at what the flexi PCB parameters are so that we can do the smallest possible traces. How to, yeah, get the engineer to do the brain vein and explain absolutely everything. I know. Yeah, anyway, so that's progress. We're going to make more tomorrow. We're going to actually be able to print this and cut it out of a piece of paper. We'll do like the board outline if we can, and hopefully maybe some traces or whatever. Yeah, Happy New Year, everybody. I hope it's going to be a good year for everybody out there. Have you considered having flexi PCB to the solder pads and then connector FR4 for the... Oh, man, it's too much work. Why not just do the whole thing on flexi PCB? It's a $2 PCB, right? $2. I could get this made for $2. It's a little bit of work routing all the stuff, but once I've routed all the stuff, bam, you know? And also the fact that I need to go 4 different directions with a... Like if I bought flexi PCB with a similar pin pitch, which I might even have some, I still run the problem of having to get the signals out of these things and then house another FR4 board. This is going to be ridiculously thin. I will be able to attach it with double-sided tape, like foam tape, to get it out of the way of the through-hole stuff. And then this portion of the board right here, I have the little flexi ability to get directly to the pin, so it'll be clean. All right, that's it for me. Here's the end card again. I'll go to the face cam now, and I can actually do the end card another time. I can go end, and then you can see that we will be back in 19 hours, 55 minutes, and 2 seconds. So you better make the best use you can of that time.